What if the coldest place on Earth wasn't always frozen? What if beneath the miles of ice there are forests, rivers, and maybe even ruins that time never meant us to see? And what if Antarctica didn't just freeze naturally, but suddenly, as if something happened there, the world has forgotten? Welcome to the 101 Archive. Tonight, we'll uncover 101 mysteries buried beneath the ice, from fossilized trees and lost continents to ancient maps that shouldn't exist and secrets locked away for millions of years. We'll travel through the impossible timeline of a continent that once bloomed with life, explore radar scans that reveal mountains no human eye has seen, and confront the questions scientists still whisper about: how fast can a world truly vanish, and what might be waiting when it wakes? Take a slow breath. Let's begin at the start, when Antarctica was green, alive, and about to disappear forever. Long before it became the planet's coldest desert, Antarctica was a living continent. You can still trace its green past through what geologists call the Transantarctica Mountains, jagged ridges that cut across the frozen interior like the backbone of a lost world. In 2016, a joint British-American expedition extracted rock cores from one of those ridges and found something no one expected: slices of fossilized wood. Their internal rings still visible, perfectly preserved. The patterns inside those trunks recorded not decades of snow, but seasons of sunlight. Scientists realized they weren't looking at driftwood that had washed in from some ancient sea. They were standing in what used to be a forest. The idea seems absurd until you compare those tree fossils with the coal seams discovered nearby. Coal is made from compacted plant matter, and yet here it lies at the bottom of the world, proof that Antarctica was once humid, green, and filled with swamp-like forests. Paleobotanists reconstructed the flora from microscopic pollen trapped in rock layers. Ferns, ginkgos, and conifers once stretched across the land where nothing now grows. It was a landscape closer to New Zealand or Patagonia than to the endless white we know today. These discoveries aligned with another breakthrough: continental drift. When the theory first emerged in the early 20th century, it explained why identical fossils appear in both South America and Antarctica. At the time of those ancient forests, the two were connected as part of the supercontinent Gondwana. Antarctica sat thousands of kilometers north of its current position, bathed in milder sunlight. But if the drift explains where it was, it doesn't yet explain how it changed so fast. Around 34 million years ago, something happened that turned a subtropical paradise into an uninhabitable ice world almost overnight. The event is still debated. Core samples suggest that global temperatures dropped sharply at the Eocene-Oligocene boundary, a period when massive ice sheets suddenly began to spread from the South Pole outward. Some researchers argue it was a natural result of Earth's orbit shifting and the opening of the Drake Passage, which allowed a cold circumpolar current to isolate the continent. Others suspect a more violent cause, a rapid atmospheric collapse, triggered by volcanic events or even asteroid impact. Either way, the transformation was total. The forests froze mid-growth, rivers hardened into glaciers, entire ecosystems disappeared beneath the ice, entombed but not erased. And yet the more we dig, the more traces of that world appear. Beneath Dome Sea, radar imaging reveals the faint outlines of ancient river valleys, channels carved when liquid water still shaped the land. These valleys flow toward basins that now sit 2 miles under ice, implying that the continent's topography has been preserved like a time capsule. Each radar scan reads the ice like a palimpsest, layer after layer of snowfall sealing away epochs. If the buried valleys once held life, they may still hold its echoes. That's the first major clue in this long investigation, the certainty that Antarctica was not always what it is now. But the second clue complicates everything, because it suggests that even after the freeze, the continent continued to hide things that should not exist. Beneath the frozen surface, Scientists using ground-penetrating radar had found what looked like entire mountain chains, the Gamburtsev Mountains, stretching across East Antarctica, roughly the size of the European Alps. They shouldn't be there. By all logic, such a massive range should have eroded long ago. The only way for it to survive intact is for it to have been buried almost immediately after its formation. Its peaks never saw sunlight in human history, yet their sharp ridges remain untouched, preserved under a protective shell of ice. Some call it the Ghost Range. Nearby, other instruments have mapped the bedrock and found magnetic signatures that don't fit the known geology. Some readings suggest dense metallic concentrations or possible impact structures, like the scars left when asteroids strike at high velocity. One particular region, beneath Wilkes Land, shows a circular gravity anomaly more than 200 miles wide, large enough to rival the crater linked to the extinction of the dinosaurs. If it truly is an impact site, it would mean that Antarctica itself helped reset the planet's biological clock. Scientists remain divided, but the signal persists across multiple satellite datasets. Then there are the lakes. Beneath 4 kilometers of ice lie more than 400 subglacial bodies of water, liquid not frozen by the sheer pressure above them. The largest, Lake Whillans, sits trapped under half a mile of ice, yet supports microbial life. When a US drilling team reached it in 2013, the samples they pulled up were alive. The discovery stunned researchers because it proved that ecosystems can survive completely sealed off from sunlight for hundreds of thousands of years. If they could exist here, similar organisms might thrive under the frozen oceans of moons like Europa or Enceladus. And still deeper, geothermal mapping has detected an unexpected heat source beneath Byrd land. The ice there melts faster from below than anywhere else in the continent, hinting at volcanic or even mantle plume activity. It's as if the frozen crust hides a second secret energy, a slow pulse from the planet's interior that refuses to die. These are tangible mysteries, measurable and real. Yet they only prepare you for the one that broke open the modern debate, a single piece of parchment drawn 5 centuries ago. In 1929, historians examining an old Ottoman atlas stumbled upon a map by Admiral Piri Reis, dated 1530. It depicted the coasts of Europe, Africa, and South America with surprising accuracy, but the lower edge showed something impossible, a detailed outline of what looked like Antarctica, drawn centuries before the continent was officially discovered. Even more astonishing, the coastline appeared ice-free, displaying mountains, bays, and river deltas that matched modern radar surveys taken through the ice. For decades, scholars tried to explain it away. Some argued it was a distorted continuation of South America. Others believed the mapmaker had copied older charts, fragments of some forgotten world atlas. Supporting this, a second map by Orance Funet in 1531 depicted a similar southern landmass with the same contours. Neither man had ever seen Antarctica. The precision was too uncanny to dismiss as coincidence. Modern comparisons using seismic data confirmed that parts of Piri Reis's coastline align closely with the true hidden shape of Queen Maud Land beneath the ice, that forced historians to confront a troubling possibility that someone, at some point before the modern era, had mapped an Antarctic region free of ice. Who they were remains unknown. The official stance is that the resemblance is accidental, an overlap of distorted latitude lines and imagination, but for others it raises a different question entirely. If such ancient source maps once existed, who made them and when? Each of these threads, fossil forests, buried mountains, secret lakes, and impossible maps, pulls you toward the same conclusion. Antarctica has not yet revealed its story. The ice preserves more than climate data. It preserves contradictions. What we call the most barren place on Earth was once fertile. What seems timeless has changed more violently than any other continent. The truth, whatever it is, lies somewhere between geology and memory, sealed in cold silence. And that silence won't last forever, because as the ice continues to thin, new shapes are starting to appear in satellite images, forms that shouldn't exist, edges too regular to be natural. Scientists prepare their instruments to study them. Others simply whisper what many are beginning to wonder. If the first forests have already resurfaced, what else might follow? The next clues lie in fossils that defy chronology. Evidence that the timeline of life in Antarctica may be older, stranger, and far less human than anyone expected. If the story ended with forests and maps, it would already challenge everything we thought we knew about Earth's extremes. Yet Antarctica's greatest revelations don't sit on the surface. They are buried deep below it, locked under miles of ice, where sunlight has never reached. What radar and drilling teams are beginning to uncover is a layered continent, older than the ice itself, a place where mountains, rivers, and even whole ecosystems still exist in a kind of frozen suspension. The first sign came from an unexpected source, radio echo sounding. When scientists began sending radar pulses through the ice, they expected to see only smooth layers of frozen water. Instead, the echoes bounced back from jagged shapes far beneath, massive peaks and valleys hidden in the dark. Those became known as the Gamburtsev Mountains, a range stretching nearly 1,200 kilometers across East Antarctica, their tallest summits as high as the Alps. Their edges are sharp, their profiles pristine. Geologists realized that such clean formations could only exist if they had been sealed away before erosion could grind them down. It meant the mountains were ancient, hundreds of millions of years old, yet preserved as if they had formed yesterday. Within those shadows, researchers mapped deep grooves that once carried flowing rivers. Radar sweeps across Dome Sea, one of the coldest points on Earth, traced ancient channels snaking for hundreds of miles. Evidence that liquid water once sculpted the land. Each riverbed now lies frozen solid, entombed beneath a translucent crust. These patterns don't just prove that water once moved freely there. They also hint at the climate rhythm that froze it all, a change so abrupt that it left the continent's hydrology perfectly intact, like a photograph developed in ice. Other data came from magnetometers mounted on survey planes. Over Wilkes Land, the instruments picked up a magnetic signature so strong that it distorted the surrounding readings. For a time, nobody could interpret it. Only when gravity mapping joined the puzzle did the image start to take shape, a massive circular depression, more than 200 miles wide, embedded in the crust. Some researchers suggested it might be a buried impact crater, possibly formed by an asteroid more than 30 kilometers across. The theory is still debated, but the numbers are striking. The impact energy would have dwarfed the one that erased the dinosaurs. If it happened, it could explain sudden shifts in the planet's climate, perhaps even the start of the Ice Age itself. Yet not every anomaly fits that catastrophic model. Some of the unusual signals come from geothermal activity, suggesting the continent is not dead, but breathing quietly beneath its frozen skin. In 2018, a study of the Byrd land region revealed heat flow patterns inconsistent with simple rock formations. There appeared to be a hot plume of magma rising from the mantle, a kind of buried volcano, slowly melting the ice above. This internal warmth has created hidden reservoirs of water, and where there is water, there is motion. That motion is visible in the most surprising places. Beneath 4 kilometers of ice near the South Pole lies Lake Whillans, a subglacial body of water completely isolated from the atmosphere. When an American research team drilled through to it in 2013, they expected sterile darkness. What they found instead was life, microbial colonies feeding on minerals and traces of methane. These organisms had survived for hundreds of thousands of years without sunlight, relying entirely on chemical reactions for energy. The discovery rewrote the limits of biology. If life can persist in total darkness beneath Antarctica, it might also exist in the subsurface oceans of distant moons like Europa or Enceladus. The same expedition also proves something subtler. The ice itself is not static. It shifts, flows, and cracks, allowing lakes to connect and drain through unseen channels. Some of these subglacial waterways move faster than rivers on the surface, Instruments have recorded entire lakes, emptying into others over just a few weeks, an invisible hydraulic system pulsing beneath the frozen crust. It's a hidden circulation that may one day carry older sediments, and possibly the traces of life, closer to the surface. As the radar surveys expanded, more lakes emerged. Beneath the Russian research base at Vostok lies the largest of them all, Lake Vostok, a dark ocean sealed beneath nearly 4 kilometers of ice. For years it was a matter of pure speculation. Then, in 2012, Russian scientists finally breached the barrier and sampled its water. What they found mirrored the earlier Willen's discovery, but on a far grander scale. DNA fragments appeared in the samples, mostly bacterial, some unclassified. At first, critics suspected contamination. Later tests confirmed that at least part of the genetic material came from genuine subglacial life forms. Some of the DNA sequences didn't match any known species. Others showed traits that could belong to extremophiles, organisms that survive in high pressure, low light, and freezing brine. The pressure and chemistry of Lake Vostok make it one of the closest analogues to the icy oceans of Jupiter's moons. Temperatures hover just below zero, yet the salt and pressure keep it liquid. It may have been sealed off for 15 million years, making it the most isolated ecosystem on Earth. Even with minimal samples, scientists suspect hundreds of unique microbial species await discovery. Whether they are ancient survivors or the descendants of surface life that adapted in isolation is still unclear. Meanwhile, heat-mapping satellites detected warm plumes rising from below the ice across several regions. In Marie Birdland, these plumes coincide with thin spots in the ice sheet, places where the surface bulges upward from geothermal pressure below. These are not active volcanoes in the usual sense. Rather, they're steady outlets of planetary heat, enough to keep water liquid but not to break through. They explain why some glaciers move faster than others, and why radar sometimes catches faint echoes that shift over months. Antarctica is less a frozen wasteland and more a sleeping machine. All these findings were made possible by technology that sees through the ice, yet they only deepen the central mystery. How much of the continent is truly unknown? Despite decades of mapping, roughly 7 million square kilometers, an area larger than Australia, remain unscanned in detail. The terrain below is uneven, filled with ridges, trenches, and hollows. Every new dataset redraws the lines of Antarctica's supposed stability. Even the atmosphere above it adds to the enigma. High-altitude sensors occasionally record gravity waves, massive oscillations in air pressure generated by the shifting ice below. These invisible ripples can travel thousands of miles, affecting weather as far away as the equator. It means the buried landscape isn't just a geological relic, it still interacts with the rest of the planet, subtly influencing storms and climate. What emerges from all this evidence is a portrait of contradiction. Under the ice lies a landscape that is both ancient and alive. Mountains that have never eroded, rivers that still flow unseen, microbes that have never known sunlight. It's a self-contained world that should not exist. Yet it does, and each discovery seems to echo the next, like fragments of a puzzle hinting at something larger. Some researchers now believe these preserved formations could even hold direct records of life from before the Ice Age. Sediments at the bottom of subglacial lakes may capture chemical fingerprints of vegetation and microorganisms that vanished millions of years ago. Extracting those layers could reveal entire ecosystems frozen mid-breath. But drilling that deep comes with risk. Even a small contamination could destroy what nature has kept pure for eons. For now, most of these lakes remain sealed, their secrets intact. Still, every expedition that returns from the ice brings fragments of information that widen the mystery. Fossilized pollen recovered from cores drilled near the coast proves that plant life survived far longer than anyone imagined, suggesting patches of warmth persisted even after the Great Freeze began. These oases could have sheltered animals, perhaps even small reptilian species, long after the rest of the continent succumbed. If verified, It would mean Antarctica's extinction was not instantaneous, but staggered, a slow retreat into silence. And there is another layer to consider. The continent's magnetic and gravitational anomalies sometimes line up in curious ways with ancient maps and legends, as if the buried geography had left an imprint on human memory. Scientists don't claim this as evidence of lost civilizations, but the coincidence keeps the imagination alive. Every mountain range detected by radar, every lake glowing faintly in sonar images, fuels the sense that we're only beginning to see what's there. For now, Antarctica keeps its distance. The ice is thick enough to hide mountains, deep enough to store climates, and vast enough to hold mysteries that span from the biological to the cosmic. As satellites refine their vision, they continue to find shapes where none should be, concentric rings, geometric ridges, patterns that flicker between natural and artificial. The data can explain some of them, not all. And so the question persists: how many more continents exist within this one, layered under its translucent shell? If the first mountains have already announced themselves through the radar, what else might lie beneath them? Cities of stone, or simply the memory of forests and seas? The next part of the story doesn't answer that question. It only pushes it further, because scattered among the ice cores and geological charts, another clue appears, one made not of rock or water, but of ink. A map drawn centuries before humans could have known any of this, outlining a frozen land that impossibly wasn't frozen at all. Maps were once the boundary between knowledge and imagination. When sailors charted unknown seas, they filled blank spaces with guesses, warnings, and sometimes myths. Yet one of those maps, drawn in 1513 by an Ottoman admiral named Piri Reis, has refused to sit quietly in history. It's a document so old it should have been replaced by better data centuries ago, and yet its southern edge continues to spark questions no satellite has settled. The map's story begins not with legend, but with mathematics. Piri Reis was a skilled cartographer who gathered source materials from across the known world. His surviving notes, written in careful Ottoman script, list ancient charts said to date back to the time of Alexander the Great. He combined them into a single image, Europe and Africa in precise proportion, the coast of South America drawn far more accurately than any European could have achieved at the time. Then, beyond the southern tip of the Americas, an unmistakable landmass appears, complete with mountain ranges, bays, and river mouths. For centuries, no one cared. The lower part of the map looked like artistic flourish until the early 20th century, when Antarctica's true coastline was first surveyed. The shock came from the resemblance. When geographers overlaid the Piri Reis map with radar scans of the subglacial terrain beneath Antarctica's ice, the match along Queen Maud Land was uncanny. It wasn't perfect, but the main features, the orientation of the peninsula, the curve of the bays, aligned too neatly to ignore. To modern scholars, this resemblance posed two possibilities: coincidence or access to an unknown source. Ottoman archives confirmed that Piri Reis had copied fragments of much older charts brought to Constantinople by captured sailors. If those charts were indeed ancient, they might have preserved geographical knowledge from a time when the Antarctic coast was still ice-free, something mainstream geology says last occurred millions of years before humans appeared. Or once Finney's 1531 world map deepened the riddle. His depiction of the Terra Australis recent's inventor mirrored the same contours, showing river deltas and a mountain spine where today's radar maps reveal buried ridges. Finney, like Reis, had no first-hand data. The duplication across unrelated sources suggested a lineage of information passed down from somewhere older than Renaissance exploration. Historians have traced the thread through medieval Portolan charts, but none explain how early drafts could have depicted a continent unseen by human eyes until 1820. To skeptics, the answer lies in geometry. Map-making before the age of longitude was prone to distortion. The southern coastline could be an exaggerated extension of South America, misplotted by degrees. But even among those who defend that view, the precision of the interior mountains remains a curiosity. When seismic surveys in the 1950s confirmed that peaks existed beneath the ice in roughly the same locations as those shown on the Piri Reis and Fine maps, debate reignited. Was it luck? Was it an intuitive projection of symmetry? Or had some forgotten culture once seen Antarctica before it froze? The notion of ancient cartographic memory is tantalizing but unprovable. Still, fragments of corroborating evidence occasionally surface. Records from early Spanish expeditions reference rumors of a land south of Magellan. Classical writers from Aristotle to Strabo speculated about a balancing southern continent required to stabilize the globe. These were philosophical ideas, not observations, but they show that the concept of a great land in the far south haunted the imagination long before discovery. Whether that imagination preserved echoes of real geography remains an open question. For geologists, the key lies not in human history, but in ice itself. Deep core drilling and satellite imaging have made it possible to reconstruct the shape of Antarctica beneath its frozen cover. When those reconstructions are compared to early maps, the fit is precise enough to sustain curiosity, yet flawed enough to avoid confirmation. The resemblance may be coincidence, but it's a coincidence that continues to draw attention from scientists and alternative historians alike. Within mainstream circles, the fascination has prompted more rigorous cross-checks. Oceanographers re-examined seafloor data to test whether the ancient coastlines depicted could have been drawn from navigational patterns rather than direct survey. The findings suggest that parts of the Antarctic Peninsula might indeed have been identifiable through prevailing current paths, which could have inspired speculative outlines. Even so, the details on the map, the river systems, the coastal bays, remain too detailed to emerge from guesswork alone. This is where archaeology meets imagination. Some researchers propose that the map makers had inherited knowledge from pre-classical civilizations capable of long-distance navigation. Others insist the apparent match is statistical noise, magnified by pattern-seeking minds. Both sides agree on one thing. The Piri Reis chart forces us to question how knowledge survives cataclysms. Could information about a warmer Antarctica have persisted through oral or symbolic transmission, resurfacing centuries later as fragments on parchment? No one can verify it, but every generation seems to rediscover the question. In the 1960s, when NASA released its first radar-derived outlines of the Antarctic bedrock, comparisons with the Piri Reis coastline circulated again, this time through scientific journals rather than conspiracy tracts. The resemblance held just enough credibility to earn a footnote in cartographic studies. The consensus view remains cautious. The map is an extraordinary artifact of Renaissance synthesis, but not a literal depiction of an ancient survey. And yet, even under that sober interpretation, it demonstrates something profound: the capacity of human observation to anticipate realities centuries ahead of technology. Beyond the academic debate, the map's very survival tells another story. The original parchment drawn on gazelle skin was discovered in 1929, folded among forgotten documents in Istanbul's Topkapi Palace. Only a fragment remains. The rest is lost. Its edges are burned, the ink faded, but the script beside the coastline reads clearly: "These lands are drawn from the maps of the ancient kings." Those words, whether boast or confession, transformed an obscure relic into a key symbol of lost memory. Subsequent studies using modern projection analysis showed that parts of the Piri Reis world align with spherical geometry that shouldn't have been known to 16th century navigators. The precision in longitude, off by only a few degrees, suggests the source charts were constructed using methods later rediscovered in the age of satellites. How such data could exist before global exploration remains unexplained. It may reflect the use of older navigational techniques based on astronomical calculation, or it may hint at observational capabilities now forgotten. Every attempt to close the debate seems to open it wider. Even skeptics admit that the coincidences are remarkably consistent. Supporters of ancient knowledge theories argue that such consistency across multiple early maps points to a deep time record of Earth's geography, one that predates the known historical timeline. The evidence is circumstantial but persistent enough to keep the discussion alive in both scientific and popular circles. The cartographic mystery bleeds naturally into the geological one. If an ancient source once depicted an ice-free Antarctica, when could that observation have been made? Ice core samples show that the last time large portions of the coast were ice-free was roughly 2 million years ago. No trace of anatomically modern humans existed then, but smaller regions, particularly along the Antarctic Peninsula, may have briefly thawed during interglacial periods as recently as 6,000 years ago, well within the span of human civilization. If early mariners from the southern Pacific or South America reached those shores, they might have seen exposed land, recorded it, and passed the knowledge northward through generations of traders. It's speculation, but it offers a bridge between impossible timelines and plausible history. Perhaps what keeps the Piri-Reis map alive is less the promise of lost civilizations than the reminder of how fragile certainty is. The document exists, the features are measurable, the correspondence undeniable, yet the chain of custody from the unknown source, charts to the Admiral's ink, remains broken. It is a perfect metaphor for Antarctica itself, fragments of truth preserved within a vast field of uncertainty. Later maps would repeat the pattern. The Orwants Fine chart of 1531, the Mercator map of 1569, and the Hondius globe of 1608 all portrayed a southern landmass with startling geographic continuity. By the time actual explorers reached those latitudes, they found only ice. The mismatch between expectation and reality deepened the mystery rather than resolving it. Today, digital analysts can overlay all these early charts onto satellite images and watch the coincidences align. Whether that alignment represents ancient accuracy or the human brain's need to find patterns in chaos is a question that no algorithm can answer. Each overlay is an act of interpretation, a dialogue between centuries. What's undeniable is that the map forced modern science to look more closely at Antarctica itself. The drive to prove or disprove the Piri-Reis theory led to some of the first systematic radar surveys of the continent. In that sense, myth produced knowledge. The legend of an ice-free coast inspired technologies that now confirm just how much lies hidden beneath the ice. And so the circle closes. The ancient chart, whatever its origin, mirrors the planet's memory in the same way that the ice cores mirror its climate. Both are records etched in layers, one of ink, one of snow, each preserving a version of a world that no longer exists. To study them is to confront how incomplete our view of time remains. Somewhere between coincidence and impossibility, the Piri-Reis map continues to whisper a simple question. How could anyone have known? And that whisper points toward the next enigma waiting beneath the ice, fossils and bones that seem to belong to worlds where no human ever walked, yet whose traces lie scattered across the frozen hills, daring us to remember. Antarctica's silence hides the sound of life that once filled it. You can read that life in the rocks, not just in the carbon streaks of fossilized trees, but in the bones and shells pressed between layers of sandstone where no sunlight has reached for millions of years. Each excavation feels like a sentence from a book written before humanity learned to speak, and the pages continue to turn in unexpected ways. Near Beardmore Glacier, just off the edge of the Transantarctic Mountains, a field team uncovered the first of these fragments in the early 20th century. The discovery came from dark shale, embedded with the remains of amphibians more than 250 million years old. Their bones were so well preserved that scientists could still trace the delicate arcs of vertebrae and the impressions of soft tissue. These creatures, similar to the early temnospondyls that once thrived in tropical swamps, should have lived thousands of miles north, not in what is now the world's coldest desert. The fossils prove that before the Great Freeze, Antarctica hosted an ecosystem of rivers and lakes teeming with life, a vast wetland rather than an empty wasteland. The finding reshaped the geological map. It confirmed that the continent was once part of Gondwana, sharing species with regions that later became South America, Africa, and Australia. The same amphibian lineages appear in ancient strata across all those continents, a record of connection long before drift tore them apart. As paleontologists sifted through the rock layers, they began to reconstruct the timeline of a land that once basked in months of daylight, then sank into months of night, yet somehow sustained life through both extremes. What came next deepened the picture. In the 1980s, researchers working in the James Ross Island Formation unearthed dinosaur bones embedded in permafrost, including the remains of a small theropod species later named Cryolophosaurus elioti. Its skull bore a strange crest like a fan frozen in mid-motion, and it lived roughly 190 million years ago when the region was still covered in dense conifer forests. These dinosaurs had adapted to a polar environment that already experienced long periods of darkness each year. Growth rings in the bones suggested seasonal metabolism. They slowed their activity during the dark months, much like modern penguins or seals adjusting to leaner times. The discovery forced scientists to rethink what polar life meant, not absence, but endurance. Similar fossils of turtles, early birds, and even flowering plants have since appeared along the Antarctic peninsula, confirming that the continent was once temperate. But some finds sit awkwardly within established timelines. In a few sediment cores near Mount Kirkpatrick, fragments of pollen turned up that belong to species thought to have vanished millions of years earlier. They imply that pockets of warmth lingered in isolated valleys long after the global cooling began, small refuges where ancient flora survived while the rest of the planet moved on. These oases might have been fed by geothermal heat, those same subglacial plumes still active today, creating microclimates that resisted extinction. Among the most puzzling finds are occasional bone fragments, whose origins remain uncertain. A handful discovered in 1982 within the Beardmore strata appeared, at first glance, oddly mammalian. They lacked the clear reptilian patterns expected from the era. Further analysis identified them as belonging to a group of synapsids, ancestors of mammals, but not of any known lineage. The bones were small, the structure refined. Some researchers suggested they represented an evolutionary offshoot that adapted uniquely to polar life. Others warned that the samples were too fragmentary for such claims. Still, the idea that complex, warm-blooded life once evolved in Antarctica before the Ice Age took hold continues to circulate quietly among paleontologists, a possibility not dismissed but not yet proven. Each discovery hints at ecosystems frozen mid-sentence. Fossilized tree trunks lie beside the remains of amphibians, suggesting forests grew almost to the water's edge. Sediment cores show alternating bands of coal and volcanic ash, evidence of cycles of eruption and regrowth. The entire continent seems to record a pattern of life, blooming, dying, and returning, until suddenly it stopped. When the Great Glaciation came, the freeze was not gradual. Climate models suggest a rapid drop of 10 degrees Celsius in less than a millennium. For entire species, that meant extinction by sunrise. The forests fossilized upright, the lakes solidified in place, and the animals that had adapted so long to twilight perished in total night. Still, traces linger that resist explanation. On several expeditions, teams have reported finding fossilized microflora in ice cores that appear far younger than expected. Some of the pollen grains match species of southern beech trees found in Patagonia today. If verified, it would mean vegetation survived on the Antarctic coast as recently as 2 or 3 million years ago, far closer to the present than textbooks once allowed. The question then becomes, where did those pockets of life hide, while the rest of the continent froze solid? One theory points to geothermal valleys, where subsurface heat could have sustained warmth beneath the ice. Another suggests periodic melts during brief interglacial windows when solar variations allowed sunlight to penetrate deeper south. The presence of these fossils challenges our sense of permanence. The world we know as immutable ice has been in different eras, everything from rainforest to savanna to tundra, and because the fossil record of Antarctica is still less than 1% explored, every new core sample has the potential to overturn an entire epoch of thought. Even the tools used to study them tell a story. When scientists analyze isotopes from these fossils, they find oxygen ratios consistent with temperatures more than 20 degrees warmer than today's average. The data align perfectly with global reconstructions of the Eocene epoch, but they also reveal sudden spikes and drops, periods of instability when the planet seemed to convulse between heat and cold. These fluctuations could have driven the rapid evolution and eventual extinction of many polar species. What makes this evidence so compelling is its consistency across multiple sites. Fossils from the Transantarctic Mountains, Alexander Island, and Seymour Island all tell the same narrative. Life was abundant, diverse, and complex, right until the climate flipped. Then the record ends abruptly, like a book torn mid-chapter. The next layers contain only dust, ash, and ice. Yet, in that abruptness, lies the first whisper of mystery. Why such an extreme transition? Volcanic eruptions and orbital shifts explain part of it, but not the speed. Something in Earth's system changed with unprecedented velocity. Some scientists propose that the Antarctic plateau acted as a trigger. As snow accumulated, it reflected sunlight, amplifying cooling until the entire planet tipped into a new state. The continent may have been both victim and cause of its own freezing. And if that's true, then Antarctica's fossil record isn't just a relic, it's a warning written in stone. It shows how fast climates can collapse, how life can vanish in geological minutes. For researchers studying modern warming, these ancient fossils serve as both guide and ghost. But the story doesn't end in the lab. Around these discoveries has grown a quiet fringe of speculation, ideas suggesting that some of the out-of-place fossils hint at forms of life not yet catalogued. A few independent researchers claim to have found hominid-like fragments among ancient sediments, though none have survived peer review. The mainstream view is clear. There is no verified evidence of human or pre-human remains in Antarctica's deep strata. Still, the persistence of those rumors reflects a deeper fascination. The notion that a lost chapter of Earth's story could lie beneath the ice, waiting for the right thaw to speak again. For now, all we can do is read what the rock allows. Each fossil, each pollen grain, each misfit bone expands the horizon of what Antarctica was and could be again. It reminds us that beneath the apparent stillness of the ice, a living history remains, paused, not erased. And somewhere beyond those frozen layers, human history itself begins to intersect with the mystery. In the mid-20th century, as nations scrambled to explore the southern frontier, one operation in particular would return with stories that blurred the line between science and myth. The fossils had shown Antarctica's ancient life. Now came reports of something encountered in the present that would make the world wonder what else survives in the cold. By the middle of the 20th century, Antarctica had become more than a scientific frontier. It was a stage for human ambition and fear. The Second World War had just ended, and much of the world remained carved into zones of secrecy. When the United States announced Operation Highjump in 1946, few outside military circles understood what such a massive deployment to a frozen wasteland could possibly be for. Officially, the mission's goal was to train personnel and test equipment in extreme cold. Unofficially, rumors began the moment the ships left harbor. The scale alone was staggering. Led by Admiral Richard E. Byrd, the expedition included 13 ships, 33 aircraft, and more than 4,700 men, a fleet size that resembled wartime logistics rather than peacetime research. Carriers, destroyers and support vessels set course for the Ross Sea, a body of water locked between towering cliffs of ice. For a place that had never known war, Antarctica was suddenly seeing one of the largest naval operations in human history. Those who sailed south expected monotony, the endless white horizon, drills, and data collection. Yet the records show a campaign that ended faster than anyone predicted. Official briefings listed a 6-month operation. The ships returned home in barely 3. Mechanical failures were blamed, as were harsh conditions, but the abrupt withdrawal left questions hanging in the cold air. At least 3 aircraft were lost, along with several lives. In the decades that followed, declassified logs confirmed a series of accidents, planes vanishing in storms, a crash during an aerial survey, and engines freezing mid-flight. None of that was unusual for the environment, but the speed of the retreat was. Some of Byrd's public statements added to the unease. In an interview published not long after the mission, he warned of new threats that could strike the United States from the poles at incredible speeds. The quote, taken out of context, became fuel for conspiracy, but the actual report referred to the strategic potential of long-range aviation. Still, the idea that something unexpected had happened on that mission refused to die. Beyond rumour, the tangible data from Highjump remains invaluable. The expedition conducted the first extensive aerial mapping of Antarctica's interior, photographing more than 220,000 square kilometres of terrain. Those photographs later formed the baseline for the continent's modern maps. They revealed features that scientists are still trying to understand: deep crevasses in the ice sheet, unexplained magnetic fluctuations, and evidence of geothermal warmth seeping from the crust. In essence, the mission provided a glimpse beneath the mask of perpetual snow. At the same time, it tested human endurance on a scale unseen since Shackleton. Men laboured in temperatures dropping below -40 degrees Celsius. Frostbite, isolation, and malfunction haunted every task. The sheer brutality of the conditions forced Byrd to reconsider what Antarctica meant for the future of exploration. His private diary, released years later, described the landscape as both inhuman and magnetic, a paradox of beauty and threat. He wrote that the continent draws men like a flame and consumes them the same way. What complicates the historical picture are the stories that never entered official archives. After the operation's early end, fragments of rumour spread through naval circles, claims of encounters with unidentified craft, of orders to retreat, of radio transmissions lost to interference. None of these stories have ever been substantiated, yet they continue to colour the mythos surrounding Highjump. What is verifiable is the mission's toll. Fatal accidents did occur, aircraft were destroyed, and a few expeditions vanished into the weather, their final coordinates never recovered. The Antarctic environment was, and remains, the most hostile on Earth. Byrd's own role became legend. Already a veteran of polar exploration, he understood the psychological cost of the ice better than most. Decades earlier, he had spent 5 months alone at a weather base on the Ross Ice Shelf, nearly dying from carbon monoxide poisoning before rescue arrived. To him, the ice was a mirror for human extremes. His decision to lead Highjump's return home has been interpreted both as strategic prudence and as response to something deeper, a realization that Antarctica was not simply a field site, but a force beyond control. What historians can agree on is that Operation Highjump marked the beginning of Antarctica's transformation from mystery to geopolitical interest. The maps it produced attracted attention from every major power. The Soviet Union launched its own expeditions within a decade, and by the 1950s multiple nations had staked territorial claims under the guise of research. In this way, Byrd's fleet opened not just a scientific era, but a diplomatic one, forcing the world to decide how to handle a continent that belonged to no one. Behind the legend, however, lies a quieter set of truths. The operation gathered thousands of samples, ice cores, meteorological data, and photographs that revealed unexpected warmth in certain regions. Instruments detected geothermal anomalies beneath the ice sheet near the same zones later identified as volcanic hotspots. These findings hinted that the continent's underbelly was alive with energy, contradicting the view of a static, frozen world. In one of the surviving logs, an engineer notes an unusual phenomenon: radio signals bending and echoing back from the surface, instead of bouncing into space. The effect, later explained by atmospheric refraction, caused navigation errors and communication dropouts that added to the sense of mystery. For men operating in a landscape of endless whiteness, every malfunction felt like the whisper of something unseen. When the fleet finally returned to the United States, it carried not treasure, but data terabytes by today's standards, and the seeds of a global fascination. The mission's abrupt conclusion and Byrd's cryptic tone provided the perfect soil for legend. Over the next decades, Highjump would be recast in fiction and speculation alike: a secret war beneath the ice, an encounter with unknown forces, a cover for early Cold War experiments. None of these narratives withstand scrutiny, yet they reveal a deeper human truth. The same instinct that led ancient mapmakers to draw coastlines they had never seen drove 20th century explorers to imagine what still lay hidden beyond their reach. What can be verified is equally extraordinary, though less sensational. Highjump's surveys identified several massive subglacial lakes, early hints of what would later be confirmed at Vostok and Whillans. The instruments of the 1940s could not penetrate as deeply as modern radar, but even then the presence of water beneath the ice seemed clear. That single finding changed the logic of polar science. If liquid existed under such pressure and cold, Antarctica might host unknown life forms, environments sealed off since prehistory. The expedition also demonstrated the limits of human endurance. In extreme cold, setting standards for equipment and survival that still influence modern missions. The insulated suits, fuel systems and snow tractors designed for Highjump became prototypes for decades of polar technology. In that sense, the mission achieved far more than the myths surrounding it. It proved that humans could operate barely in conditions once deemed fatal. Byrd's later writings softened into reflection. He spoke of Antarctica as a continent of peace, and advocated for its protection as a shared scientific domain. His vision eventually materialized in the 1959 Antarctic Treaty, signed by 12 nations. The treaty forbade military activity, preserved the land for research, and declared that the continent's mysteries were to be explored, not conquered. Without the data, imagery, and even the myths born from Highjump, that agreement might never have existed. Yet one detail remains impossible to shake: the mission's eerie finality. For all its success, the records stop abruptly. After March 1947, the fleet's logs grow terse, the descriptions minimalist, as though language itself froze. It's as if the ice taught silence. In those unrecorded spaces between entries, imagination still moves, the idea that something vast and unknowable waits beyond the reach of reason. When later expeditions returned to the same regions mapped by Byrd's pilots, they found the terrain subtly changed. Crevasses widened, ridges collapsed, and magnetic anomalies shifted location. The continent is never still. It swallows evidence as easily as it preserves it. Whatever truly happened during Operation Highjump, the ice has long since folded it into itself, storing it alongside fossils and forgotten rivers. What remains is a paradox worthy of the place. An operation meant to chart and conquer the unknown, instead ended by reaffirming it. The continent that swallowed its own forests and mountains swallowed a piece of modern history too, leaving behind data points, human loss, and an echo of ambition frozen into the wind. And from those winds, another mystery soon emerged. A body of water sealed off from the world for 15 million years, harbouring secrets that no expedition, military or otherwise, had ever touched. What lay beneath that ancient lake would pull scientists back to the pole once more, not with warships but with drills, seeking life where none should exist. Beneath the clean white silence of the East Antarctic Plateau, lies a world no sunlight has ever reached. Pressure there is crushing, the temperature constant, below freezing, yet liquid because of sheer weight and the planet's hidden warmth. Scientists call it Lake Vostok, though what they mean by lake barely fits the image the word suggests. It is an inland sea, sealed under almost 4 kilometers of solid ice, invisible until radar first traced its outline in the 1970s. What began as a faint echo on a Soviet survey screen became one of the most haunting discoveries of modern science. For decades, the lake existed only as rumor in data. Then, in the winter of 2012, a Russian drilling team finally broke through. Their borehole was narrow, no wider than a wrist, and the risk immense. The difference in pressure between the water below and the ice above could have triggered an explosion. Yet, when the drill touched liquid, what surged upward was not steam or mud, but clear, compressed water, older than any civilization. Samples froze instantly upon contact with the air, and when scientists later melted them in sterile labs, they found traces of something alive. The genetic analysis revealed DNA fragments belonging to bacteria unknown to science, organisms that did not match any catalogued lineage. Some researchers argued contamination, others insisted the results were genuine. The second drilling season yielded sequences still unclassified, suggesting a unique ecosystem evolved in isolation for at least 15 million years. The creature's biochemical markers hinted at metabolisms powered by iron and sulfur, rather than sunlight, an echo of life's earliest forms. It was as if the lake had been preserving Earth's microbial past, continuing it beneath the weight of time. Outside the lab, the implications stretched farther than the continent. Astrobiologists immediately drew parallels with the oceans beneath Europa and Enceladus, moons where ice covers potential liquid water. If bacteria could thrive in Lake Vostok's darkness, then life elsewhere in the solar system no longer seemed a miracle, but a probability. Antarctica, long imagined as dead, had become a rehearsal for alien discovery. Even within terrestrial boundaries, Vostok defied expectations. Temperature readings showed the lake warmer than the ice above, hovering near the freezing point due to pressure and geothermal heat. Its volume, more than 5,000 cubic kilometers, made it the world's 6th largest freshwater body. Yet it sits entombed, unseen by human eyes, every molecule part of a closed cycle. Water there may take thousands of years to circulate once, moving slowly under glacial weight. Scientists compare it to blood flow through a heart frozen in time. The first analyses of gas bubbles trapped in the overlying ice core added another layer to the mystery. Oxygen concentrations reached levels that would be toxic to surface organisms. In theory, any microbe living below must have evolved extraordinary defenses against oxidation. This finding reinforced the idea of a distinct biosphere, one shaped by extremes of pressure, radiation, and chemistry rather than climate or sunlight. In a sense, the lake is an evolutionary museum, each microbe a surviving curator of an epoch long vanished. Not far from Vostok, other subglacial bodies have come to light. Lake Whillans, drilled by an American team in 2013, proved the earlier discovery was no anomaly. Beneath 800 meters of ice, the Whillans samples contained active microbial colonies feeding on minerals and methane. DNA sequencing identified more than 3,000 species, all microscopic but astonishingly diverse. The samples showed metabolic signatures of organisms converting iron and sulfur into energy, processes identical to those found near deep ocean hydrothermal vents. It confirmed that sunlight is not a prerequisite for life. Chemical energy alone can sustain entire ecosystems. These findings, scattered across hundreds of hidden lakes, hint that the Antarctic crust may host a continuous web of subglacial water. Some basins drain into others through channels that open and close with the rhythm of the ice sheet's movement. Satellite altimetry has recorded whole lakes, emptying over weeks, then refilling from elsewhere. The continent, long thought static, breathes through these unseen arteries. In some regions, the water's origin remains uncertain. Isotopic studies show part of it is melted glacial ice, but another portion seems ancient, trapped seawater from an epoch when Antarctica was still coastal forest. If so, those pockets preserve not only microbial life, but chemical memories of prehistoric oceans. Each drilling project becomes a controlled intrusion into deep time, touching water that may not have mixed with the atmosphere for millions of years. Pressure and temperature beneath the ice can generate phenomena bordering on the surreal. Sensors lowered into boreholes detect rhythmic vibrations, soft pulses that ripple through the surrounding strata. Geophysicists interpret them as ice cracking and refreezing under stress, but the pattern's regularity evokes something almost biological, as if the glacier itself had a heartbeat. Every measurement challenges the definition of lifeless. Further west in Marie Byrd land, satellites record heat fluxes higher than any other point in the Antarctic interior. Beneath those coordinates lies what researchers call a mantle plume, a slow, rising column of magma warming the crust from below. It's not a conventional volcano. Its energy dissipates gradually, melting ice into subglacial lakes and lubricating the movement of the overlying sheet. This hidden warmth may explain why some glaciers there slide toward the sea faster than models predict. It also keeps certain basins in a perpetual state of melt, maintaining habitats that have existed continuously since long before modern ice formed. Taken together, these discoveries redraw the mental image of Antarctica. It is not a continent of inert ice, but a layered world, frozen at the surface, alive beneath, hot at the core. Where the temperature gradient narrows, microbial activity rises. Where the pressure peaks, water remains liquid. This dynamic equilibrium sustains conditions that defy textbook logic. Instead of an endpoint for life, the pole becomes one of its most resilient sanctuaries. Even the technology used to probe these depths evolves alongside the discoveries. The drills are sterile by necessity, their lubricants replaced with non-reactive fluids to avoid contamination. Engineers design them like spacecraft, aware that the data they gather may inform missions to other planets. Each new borehole thus serves a dual purpose: to study Earth's history and to prepare humanity for exploration beyond it. The scientists themselves speak of their work in reverent tones, aware that a single droplet from those depths might carry the oldest DNA on Earth. When samples from Vostok were thawed in controlled conditions, one surprise overshadowed the rest. Alongside bacterial sequences appeared faint traces of more complex eukaryotic DNA, possibly from multicellular organisms. The evidence is fragmentary, but if confirmed, it would mean tiny animals or fungi once lived, and perhaps still live beneath the ice. The hypothesis remains controversial, yet the fragments resist easy dismissal. Their existence hints that isolation doesn't merely preserve the past, it allows evolution to follow its own silent course. Even without life, the lake holds clues to global climate. Gas ratios inside its overlying ice core show transitions marking ancient greenhouse and icehouse phases. Each bubble acts as a time capsule of Earth's atmosphere at the moment it froze. By reading them, climatologists reconstruct 420,000 years of history, cycles of carbon, temperature, and volcanic dust. Those records link directly to global extinction and recovery events, tying Antarctica's story to the fate of every ecosystem on Earth. The frozen continent, once thought peripheral, turns out to be central to understanding planetary balance. For all the progress, a boundary remains. The main body of Lake Vostok itself has never been entered by human instruments. International treaties and scientific caution forbid direct intrusion until sterilization methods can guarantee no contamination. The lake remains sealed, its surface unbroken, except for the hairline borehole, now refrozen above it. Somewhere below, currents continue their slow rotation, untouched since long before the first human word for ice existed. Every expedition that returns from the pole leaves with more questions than answers. The deeper they drill, the less they can claim certainty. What began as a search for geology has become an inquiry into life's persistence under Antarctica's crushing pressure. Scientists glimpse not extinction but endurance, a biosphere thriving in silence, unaware of the surface world. It's that paradox that draws them back. A place colder than death, yet filled with traces of vitality. Each core sample is both fossil and prophecy, proof that the line between past and present can blur beneath the ice. And as researchers study those microscopic survivors, their attention shifts once again toward the sky. If such life can exist here, what forms might dwell in the frozen oceans of other worlds? The answers remain buried in the dark, suspended between continents of time, but the drill marks above Lake Vostok stand as evidence of the moment humanity reached beneath the planet's oldest glacier and touched the edge of another epoch, proof that even the coldest silence can whisper life. Across Antarctica's wastelands, the ice guards more than biological secrets. It holds pieces of the universe itself. Every winter, while the wind polishes the snow into glass, the continent collects messages from space. The air is thin, dry, and almost perfectly clean, which makes Antarctica the best meteorite trap on Earth. Rocks that fall here don't corrode or sink into soil. They wait, visible against the white, until human eyes find them. In that stillness, the planet receives a constant drizzle of ancient debris, silent records of how our solar system began. One of the most famous finds came from a patch of blue ice at Allen Hills in 19. A small rock, barely 2 kilograms, lay embedded in the surface. It was catalogued as ALH-8401, just another Martian meteorite among thousands collected over decades. Only when scientists cut it open did its true strangeness appear. Inside the cross-section, under the microscope, were ovals and tubules shaped like microscopic fossils, too small for certainty, but unmistakably organic in outline. NASA researchers announced the finding in 1996, suggesting the structures might be traces of ancient Martian microbes. The world erupted with fascination. If true, it would be the first direct evidence that life once existed beyond Earth. Skeptics countered quickly. They argued the forms could result from chemical reactions, not biology. Later studies of carbon isotopes and magnetite crystals left the question unresolved. The rock could be either a fossil or an extraordinary piece of geology, mimicking one. Decades later, the debate still flickers, half science, half philosophy. Yet regardless of its origin, ALH-8401 transformed how scientists viewed both Mars and Antarctica. It showed that the frozen continent is not simply a museum of Earth's past. It is a gallery for the cosmos, preserving whatever the sky chooses to send. Meteorites fall everywhere, but only here do they accumulate without decay. Each year, glaciologists trek into the transantarctic mountains, where katabatic winds sweep snow away and expose dark stones on the blue ice. The process is elegant. Glaciers carry embedded meteorites for centuries, grinding them towards surface pressure ridges. When melting occurs at the same rate as glacial flow, the stones remain trapped at the surface, forming dense fields of extraterrestrial material. In some regions, explorers can collect hundreds in a single day, ranging from millimeter dust to half-ton fragments. Each one is older than any terrestrial rock, and each one adds another line to the solar narrative. Analysis of these stones has revealed a continuous record of cosmic events. Their isotopic signatures show the timing of ancient solar flares, supernova dust, and collisions between planetary bodies. Some contain pre-solar grains, particles older than the Sun itself, embedded in a matrix of fused minerals. Others carry organic molecules, amino acids formed in space long before life emerged on Earth. The ice in its neutrality keeps them pristine. To scientists, Antarctica functions as both freezer and archive, a place where time stops long enough for the universe to be studied in fragments. Among these fragments, another category stands out: meteorites, containing glassy inclusions from impact events on our own planet. When asteroids strike Earth, the explosions melt surface rock and eject it into the sky. Some of that molten debris rains back down near the poles, where it's preserved in the ice. Counting and dating these pieces allows researchers to reconstruct a chronology of ancient impacts, some of which correspond to mass extinctions. The data confirm that the Antarctic sheet has silently recorded every catastrophe for at least 2 million years. Meteorite ALH 8401 may be the most famous, but it is not alone. Over 45,000 meteorites have been retrieved from Antarctica since the 1970s, forming a global database unmatched in scope. Each specimen tells a different version of the solar story: fragments from the Moon, from Mars, from asteroids shattered in the belt between Jupiter and Earth. Some even contain minute bubbles of gas whose composition perfectly matches the Martian atmosphere measured by probes. To hold such a rock is to hold a piece of another world, carried by chance across interplanetary space, resting now in the planet's coldest cradle. The chemistry inside these stones also helps decode the history of our own Sun. By studying isotopes like neon-21 and argon-38, scientists calculate cosmic ray exposure ages, determining how long a meteorite traveled through space before arriving here. These ages sometimes reach hundreds of millions of years. The data reveal cycles of solar activity, bursts of radiation, quiet epochs, and the steady heartbeat of a star breathing across geological time. Antarctica, through its meteoritic harvest, becomes a solar observatory written in stone. The discoveries also remind us that the boundary between Earth and sky is porous. Every particle of dust settling on the ice carries cosmic information, radiation histories, magnetic orientation, and the fingerprints of stellar processes. The continent's own magnetism interacts with this rain of matter, subtly recording fluctuations in the planet's magnetic field. By cross-referencing meteorite chemistry with polar ice layers, scientists can trace how Earth's magnetosphere shifted and shielded life through eons. The story is one of constant negotiation between the heavens and the ground beneath. These extraterrestrial arrivals have practical value too. The isotopic ratios they carry help calibrate dating methods used across geology and archaeology. When researchers study ancient Antarctic meteorites, they refine the same radiometric clocks that measure human prehistory. The rocks from the sky thus connect planetary evolution to our own fragile timeline, a reminder that the universe's chronology and ours are written in the same dust. Some of the finds are almost artistic in their improbability. Tiny metallic spheres, no larger than a grain of salt, pepper the surface snow near the South Pole. Under microscopes, they glint like forged jewelry, perfect spheres formed by melting during atmospheric entry. Each weighs almost nothing, yet together they represent the planet's continuous communion with space. These micrometeorites fall by the billions each year, embedding themselves in every new layer of ice. Future scientists drilling cores from today's snow will find them as we now find ancient fossils, a testament to what the sky was doing when our age began. The connection between the cosmic and the terrestrial becomes even clearer when examining Antarctica's role in studying radiation. Cosmic rays, high-energy particles streaming from distant galaxies, strike the atmosphere, producing showers of secondary particles. The purity of the Antarctic air allows detectors to register these interactions with unprecedented clarity. Projects like the IceCube Neutrino Observatory, buried deep within the ice, now listen to those invisible messengers, tracking neutrinos that have crossed billions of light years. In this sense, the same medium that preserves meteorites also serves as a telescope, letting us read the universe's faintest whispers. Yet for all the precision of these measurements, the most haunting detail remains the quiet coincidence of place. The coldest, emptiest region on Earth has become the repository for matter from everywhere else. It collects what the world above discards: fragments of Mars, of the Moon, of vanished asteroids. The landscape that seems most isolated is paradoxically the most connected. Every rock found there is a handshake between worlds. The scientific consensus is cautious but awed. Meteorites from Antarctica have confirmed theories about planetary formation, solar chemistry, and even the early presence of water in the solar system. Some contain minerals that can only form in liquid water, implying that their parent bodies once hosted oceans, or at least transient warmth. These clues help reconstruct how Earth itself gained its seas. The frozen desert thus teaches us about the origin of the element that now buries it, water. Each expedition that ventures out onto the blue ice fields follows a ritual. Scientists move in lines, eyes scanning for glints against the monochrome. When a dark shape appears, they halt, photograph, and collect it with sterile tools. Every sample is wrapped, labelled, and flown to laboratories, thousands of miles away. The process is methodical, but every find still carries the thrill of a miracle, a stone older than the continents, fallen from beyond imagination, waiting patiently in the cold for discovery. The data gathered from these stones has even refined our understanding of Earth's motion. Microscopic magnetic inclusions inside certain meteorites align with the planet's field at the time of impact, offering a secondary record of geomagnetic reversals. When combined with ice core analysis, these samples create a synchronized timeline of cosmic and terrestrial history, showing how solar storms, magnetic shifts, and climate events interweave. In effect, each meteorite is both artifact and instrument, translating celestial rhythm into earthly record. For all its grandeur, this cosmic archive is fragile. As climate change melts the ice sheets, meteorite fields risk being buried or lost in runoff. Scientists now race against time, retrieving what they can before the blue ice retreats. It's a quiet irony. The same warming that might one day reveal hidden valleys and fossils could erase the sky's oldest messages from Earth's surface. The ice gives and takes in equal measure. Perhaps that is Antarctica's ultimate role, to remind us that preservation and destruction are twin processes. It stores the memory of forests and oceans, of vanished species and incoming stars. When you hold a meteorite found there, you are touching both the earliest past and the furthest distance. The fossils told us what the continent once was. The meteorites tell us what the universe once dreamed it could be. And together they whisper that the boundary between earth and sky, between living and inert, is far thinner than we ever believed. Soon attention would turn from the heavens back underfoot, where radar had begun to reveal patterns that were neither starborn nor biological, shapes under the ice whose magnetic echoes hinted at something vast, dense, and hidden. The next clues would come not from space, but from the strange signals rising from the depths of Wilkes Land, a region where the planet itself seemed to remember an impact older than history. The deeper the radar looked, the stranger Antarctica became. From above, the ice seemed an unbroken sheet, immovable, ancient, eternal. But deep scanning satellites and magnetometers began to tell a different story, one of tension and buried movement, as if the continent carried scars no one had ever seen. It was over Wilkes Land, an expanse roughly the size of Greenland, that the first anomaly appeared, a circular concentration of gravity so strong that it bent the readings of every satellite passing overhead. NASA's gravity mapping satellites measured it again and again. The data did not change. Something massive and unusually dense was buried a kilometre beneath the ice. Its signature stretched over 300 miles in diameter, far larger than any mountain or volcano known on the continent. For some, it resembled the magnetic outline of an impact crater. For others, it suggested a dense metallic core or a magma chamber long dormant. The anomaly's sheer scale evoked planetary catastrophes, events that could have rewritten Earth's climate in an instant. To understand what such a signal meant, geophysicists compared it to known impact sites, like Chicxulub in Mexico. The numbers were chillingly similar. If a meteorite of comparable size struck Antarctica, the energy would have been enough to tilt global temperatures, release megatons of vaporized rock, and possibly initiate the cooling that froze the continent. Ice cores from nearby regions showed thin layers of iridium an element rare on Earth but common in asteroids, dated roughly 250 million years ago, close to the boundary between two mass extinctions. Some researchers began to suspect that the Wilkes Land anomaly might mark the site of an impact that reshaped not just Antarctica but the biosphere itself. Skepticism came fast. The geometry was too perfect. Some argued the measurements might reflect magnetic minerals formed during tectonic shifts rather than a crater. Others noted that no shock quartz or ejector fields, standard evidence of impact, had yet been found. The debate turned into a dialogue between data and doubt, with each new scan deepening rather than resolving the mystery. Even so, the anomaly remained. It refused to flatten into coincidence. Meanwhile, gravity sensors, installed along the continental ridge, began registering mass concentrations in other sectors of the ice sheet. These mascons, as planetary scientists call them, often indicate dense subsurface structures, sometimes metal, sometimes volcanic basalt. One theory proposed that the Wilkes Land anomaly hides a mantle plume frozen in mid-ascent, a column of superheated rock arrested by the sudden arrival of the Ice Age. Another view sees it as the preserved scar of the supercontinent Gondwana's breakup, the last breath of tectonic violence before the world quieted. Both explanations carry fragments of truth. Neither satisfies the magnitude of the readings. Even the ice itself seems to respond to whatever lies beneath. Radar soundings show distorted flow patterns above the anomaly. Glaciers bending and accelerating as though drawn toward a hidden gravitational center. The surrounding ice shelves crack more frequently than models predict, and geothermal flux in the region is among the highest measured anywhere in Antarctica. To those studying the data, it's as if something below is still releasing heat, refusing to die. Beyond Wilkes Land, smaller but equally perplexing signals dot the continent. In Queen Maud Land, a region first surveyed during the 1938 German expedition, magnetic readings fluctuate erratically, forming geometric grids rather than natural scatter. The anomalies might come from mineral alignment, but their symmetry challenges random formation. Each new pass of the satellites sharpens the lines. The shapes are not regular enough to be artificial, not irregular enough to be dismissed as chance. These patterns remind researchers how little they know of the bedrock beneath 4 kilometers of ice. Only a few % has been imaged in high resolution. The rest is extrapolation, mathematics stretched across darkness. When computers render those maps, the continent beneath the ice looks nothing like its surface. Mountain ranges intersect trenches thousands of meters deep. Volcanic domes rise beside basins filled with subglacial lakes. The entire landmass seems sculpted by forces both ancient and ongoing. In one recent study, a team of British geologists used aeromagnetic data to reconstruct what they call Antarctica's hidden geology. They found that the continent's crust is not uniform, but a patchwork of ancient fragments welded together. Some regions share signatures with Africa and India, relics of the time when all were part of Gondwana. Others show compositions found nowhere else on Earth. The Gamburtsev Mountains, long believed extinct, appear to sit atop a hot, buoyant root, an ancient crustal seed that refuses to cool completely. The heat rising from such depths creates localized melt zones, areas where the base of the ice sheet rests on water rather than rock. These zones act like lubricants, allowing the ice to flow faster toward the sea. Some scientists suspect that these very heat pockets control the movement of major glaciers like Totten and Lambert, both of which drain massive portions of the interior. In this sense, Antarctica's stability depends not just on climate, but on the hidden fires of the planet's core. Magnetometers mounted on aircraft have traced the edges of these melt zones with eerie precision. The data lines ripple across computer screens like electrocardiograms, pulses of invisible energy mapping the continent's heartbeat. When combined with radar imaging, they reveal a landscape in motion, one where magnetic fields twist and drift as if alive. The concept of a dead continent collapses under such evidence, The Antarctic interior vibrates with subterranean life, geological rather than biological, but no less dynamic. Occasionally, these signals interact with human instruments in unsettling ways. Survey drones flying over certain coordinates near Wilkes Land report unexpected compass deviations, even temporary loss of GPS lock. The cause is almost certainly electromagnetic interference from mineral formations. Yet the effect feels supernatural to those on site. In the desolation of the polar plateau, every unexplained flicker acquires mythic weight. Still, data continues to accumulate. Seismic tomography, using earthquake waves to image the Earth's interior, has recently confirmed the existence of a dense structure, roughly 500 kilometers wide, beneath Wilkes Land. Its boundaries match the earlier gravity anomaly almost exactly. Whether this structure is an impact remnant, a buried asteroid core, or simply an unusually solid section of crust remains unresolved. But its density is extraordinary, comparable to metallic ore bodies, far beyond ordinary rock. Elsewhere, the readings soften into poetry. In some sectors, radar captures faint, concentric rings beneath the ice, patterns that mirror the growth lines of trees. Glaciologists interpret these as frozen flow records, layers compressed by age. Yet, even in scientific reports, the metaphors slip through. Antarctica as an organism, its history written in circulatory loops. Each anomaly becomes an organ in that hidden anatomy, heart, vein, lung, each performing a function we have yet to understand. As the ice shifts and melts, these subterranean heat sources may shape the future as they once shaped the past. Warm plumes beneath Thwaites and Pine Island glaciers accelerate their retreat, contributing to global sea level rise. The same energies that preserve subglacial lakes also threaten to unleash them. It's a delicate equilibrium. If too much heat rises, entire cavities could collapse, releasing floods capable of altering ocean currents. Antarctica's mystery is not merely academic, it is planetary. The question that haunts researchers isn't just what lies beneath, but why the pattern exists at all. Why should such vast magnetic and gravitational anomalies cluster in regions already rich with subglacial lakes and mountain ranges? Is it coincidence, or are we glimpsing fragments of a deeper architecture, remnants of processes that shaped not only this continent, but perhaps the distribution of continents themselves? For now, the instruments continue their patient listening. Each year, satellites sweep the same tracks, refining the maps, transforming uncertainty into pixels. Yet the central truth remains unchanged. Beneath the most lifeless surface on Earth lies a landscape trembling with potential. Its signals cross the thin boundary between science and myth, inviting both interpretations without surrendering to either. The deeper we look, the more Antarctica resembles a mirror turned inward, reflecting not just the planet's history, but our hunger to explain it. The magnetic fields hum their coded messages, gravity tugs invisibly at the ice, and humans, still learning to translate, keep returning with sharper tools and deeper questions. Somewhere below Wilkes Land, a mystery sleeps under miles of frozen silence, dense enough to warp gravity itself, patient enough to wait for the next century of inquiry. And as that inquiry unfolds, the next revelations drift upward through the ice cores, fragments of genetic material, ancient DNA still viable after millions of years, whispering that even under such crushing depths, life may have found a way to endure. The idea that Antarctica could still contain traces of life from a vanished world sounds poetic until you see it under a microscope. Deep in government freezers, test tubes hold water melted from ice cores, drilled far below the continent's surface. Each vial glows faintly under ultraviolet light, and within that glow are fragments of ancient DNA, evidence that life, microscopic and persistent, has survived the planet's most brutal cold. The first of these revelations came from cores extracted near the Ross Ice Shelf. Technicians expected sterile samples. After all, the ice had been locked away for millions of years. Yet when they sequenced the contents, they found recognizable genetic material, strands belonging to marine plankton that once floated in warm seas. These fragments dated back roughly 2.7 million years, a time when the climate allowed open water around parts of the continent. The discovery proved that Antarctica's ice doesn't erase history, it preserves it. Every layer of frozen water is an archive of atmosphere, pollen, salt, and genetic dust from the world that existed when that layer first formed. The process of reading that archive is delicate. Scientists melt the ice in sterile chambers, filter the water for cells, and amplify the genetic material through polymerase chain reactions so that each fragment can be identified. What emerges is a molecular census: bacteria, algae, and viruses that lived and died before humans ever appeared. Some of these sequences match known species still living in today's oceans, suggesting evolutionary continuity across millions of years. Others, though, defy classification. They show mutations unlike anything recorded in databases, implying lineages that diverged before the modern biosphere took shape. Contamination remains the great concern. Researchers double-check every result, comparing it with the DNA of those who handled the samples. Yet, even after rigorous controls, several sequences remain truly foreign. One such fragment, found at a depth of nearly 4 kilometers near Dome Sea, contains genetic markers unlike any terrestrial phylum. Some suspect it could belong to a now extinct form of bacteria, adapted to subglacial pressure and extreme isolation. Others entertain a bolder possibility that microscopic life may have arrived via meteorites, the same cosmic messengers that deliver amino acids to every corner of Earth. Either way, the ice has kept it intact, an evolutionary message in a bottle. When scientists discuss these findings, their tone alternates between awe and caution. The evidence doesn't imply lost civilizations or mythical species. It shows that even after millions of years of darkness, life refuses to vanish completely. DNA strands can persist, dormant but recognizable, carrying echoes of ecosystems that once thrived on sunlit seas, now buried under ice. Antarctica, in this sense, is both tomb and seed bank, a frozen repository for the planet's memory. Deeper still, at the base of subglacial lakes, sediments contain organic molecules that resist decay. Drilling teams retrieved cores of dark mud from Lake Willans, and inside those cores were living microbes metabolizing sulfur and ammonia. These organisms had been isolated since before the last ice age, surviving on chemical reactions alone. Genetic sequencing revealed relatives of bacteria found around deep-sea vents, suggesting that similar adaptations occur wherever energy can be drawn from rock rather than sunlight. Evolution, it seems, always finds a foothold. The same pattern emerges in Lake Vostok's samples. Within its sealed waters, biologists found DNA fragments that don't match any modern catalogue. Some sequences resemble aquatic species known from tropical environments, which seems impossible under current conditions. A minority of scientists argue contamination. Others propose a different explanation, that these genes belong to ancient ancestors of those warm water species, trapped when the continent froze. If true, then the lakes beneath Antarctica are not isolated anomalies, but time capsules of pre-ice life, holding genetic lineages that might have vanished elsewhere. In recent years, advances in metagenomics have allowed researchers to reconstruct entire microbial genomes from these fragments. The results paint a picture of ecosystems that once thrived in warmth and later adapted to darkness. Some of the reconstructed organisms possess metabolic pathways, optimized for iron reduction, an energy process efficient under high pressure and low oxygen. Such pathways mirror those hypothesized for life on early Earth, linking Antarctica's present microbes to the planet's primordial past. In effect, the continent functions as a living fossil, sustaining biochemical strategies billions of years old. Even more compelling are the discoveries made through isotopic dating. By comparing nitrogen and carbon ratios in the organic remains, scientists determined that some microbial colonies have been active continuously for hundreds of thousands of years, reproducing slowly but steadily beneath the ice. This continuity challenges the assumption that glaciers are sterile. Instead, the ice may act as a semi-permeable shield, allowing tiny amounts of nutrients and gases to circulate. In this subterranean twilight, bacteria live at the limits of metabolism, dividing perhaps once a century, yet never dying out completely. Not all findings are easily accepted. A few cores from deep drilling projects have yielded unexpected genetic signatures, fragments resembling those of multicellular organisms, possibly small worms or crustaceans. The evidence is fragmentary and no physical remains have been recovered, but the DNA patterns are distinct enough to raise eyebrows. Could larger life forms have once inhabited these buried lakes? The scientific answer is a careful perhaps. Even if such species existed, they would have been microscopic or dormant, surviving in suspended animation until conditions shifted again. As if to confirm that possibility, modern samples sometimes show signs of recent biological activity. When cores from Lake Mercer were melted in 2019, sensors detected spikes of methane and carbon dioxide, gases typically produced by respiration. In controlled incubations, the microbes from that lake resumed metabolism after tens of thousands of years in darkness. They began to consume oxygen and release carbon compounds, proof that their dormancy had not been death, but pause. The boundaries of life's endurance stretched once more. The implications extend beyond biology. These findings force climatologists to reconsider how ecosystems respond to ice ages. If microorganisms can survive sealed away for millions of years, then global freeze events may not erase life, but simply hide it. When warmth returns, reawakening follows. The Antarctic ice sheet, in this view, is a planetary hard drive storing dormant versions of Earth's own biosphere, waiting for reboot. Researchers have begun to apply these lessons to exoplanet studies. The techniques used to detect ancient DNA now guide the design of instruments for Mars and the icy moons of Jupiter. In workshops, planetary scientists openly refer to Antarctica as the blueprint for extraterrestrial survival. The samples extracted from its depths will train future explorers to recognize alien biochemistry when they see it. Thus, the continent becomes not only Earth's last frontier, but the model for all others. There is also a quiet, philosophical echo in these discoveries. Every genetic fragment recovered from the ice blurs the line between past and present. The microorganisms identified in subglacial samples may be the direct descendants of species that predate humanity by millions of years, yet they remain alive, evolving at glacial speed. Time inside the ice behaves differently, stretched, patient, circular. The oldest DNA found so far may represent lineages that never went extinct, only slowed to the rhythm of freezing and thawing. Each drill core, carefully sealed in sterile casing, carries both promise and peril. Introducing modern microbes could contaminate ancient ecosystems, erasing the very records we hope to study. For this reason, international protocols now limit access to the deepest lakes. The Antarctic Treaty's environmental clauses have evolved into a kind of ethical code, curiosity balanced with restraint. The scientists who handle these samples often describe the experience as spiritual, as if they were touching the threshold between life and its absence. In the end, the mystery of Antarctica's DNA is not just about what lives there, but about what it means to be alive. Even fragments, broken chains of nucleotides preserved in ice, retain the potential to rebuild, to be read, to inform. The cold did not kill them, it simply slowed their conversation with the world. Each sequence, when decoded, adds another voice to the chorus of Earth's history. And as that chorus grows, another voice begins to surface from the archives of human exploration. A set of pages, half lost, written by a man who once flew across the same white expanse and claimed to see warmth where none should exist. The genetic evidence says the past lives beneath the ice. His report hinted that something far stranger might lie above it. In the winter of 1947, a brief entry in a flight log began one of the strangest chapters in polar history. Admiral Richard Evelyn Byrd, already known for his earlier expeditions and for leading Operation Highjump, recorded a flight that, according to legend, should have been impossible. He took off from a base near the South Pole and disappeared from radio contact for several hours. When he returned, the official account stated little routine mechanical difficulties, adverse weather, nothing extraordinary. But somewhere in the decades that followed, a story began to grow around those missing hours, a story that still refuses to fade. The document at its center, the so-called Lost Diary, appeared long after Byrd's death. In it, the author describes flying beyond the mountains and discovering a valley of warmth, a region filled with vegetation, strange light and signs of life. The pages speak of a world hidden within the poles, inhabited by advanced beings who communicated telepathically and warned of humanity's self-destruction. The prose reads more like allegory than report, yet for many it became proof that something extraordinary had happened. Historians who have examined the surviving records agree on one point: the diary is not authentic. The handwriting differs from Byrd's confirmed journals, and the technical details of flight paths and coordinates do not match navigation records. The text likely originated in the 1950s during the height of Cold War fascination with hidden civilizations and flying saucers. Still, the legend's persistence says something about the magnetism of the unexplored. In the public imagination, the hollow Earth idea merged with Antarctica's real unknowns, its subglacial lakes, its buried anomalies, until fact and fable became indistinguishable. What remains undeniable is that Byrd's 1947 expedition was real, and it was dangerous. He flew hundreds of miles beyond previously mapped regions, documenting the terrain with cameras and magnetometers. Some of the imagery revealed patches of geothermal heat, places where bare rock and liquid water appeared amid the ice. These thermal zones, now well documented, may have inspired later interpretations of warm valleys. When the Mythic diary speaks of a land beyond the mountains, it echoes genuine data, areas where volcanoes like Mount Erebus and Mount Sidley emit constant heat, creating snow-free craters even in midwinter. The tension between the legend and the evidence has endured for decades. In 1956, when another US Navy flight reached the pole, reporters again quoted Byrd's older warning about threats that can strike from the poles. The line, originally about long-range bombers, was recast as proof of secret knowledge. It fed directly into Cold War mythology, where Antarctica became a blank screen for projection, an ideal stage for hidden bases, UFOs, and unacknowledged technologies. Yet behind the fog of speculation, small pieces of truth remain. Some of Byrd's flight records were indeed classified for years, mainly because they contained magnetic readings, valuable for navigation. When released, they revealed anomalies, unexpected deviations in compass data that correspond to regions of high iron content beneath the ice. Such variations were common, but at the time they puzzled pilots and gave rise to the idea of magnetic portals near the pole. What the instruments recorded was the distortion of Earth's magnetic field by buried formations, likely the same mascons later mapped by satellites. The mystery was geological, not extraterrestrial, but it added fuel to the mythic fire. Throughout the 1950s and 60s, fragments of this story appeared in pulp magazines and radio programs. Each retelling embellished the details. The warm valley became a hidden city. The lost diary became a suppressed government file. By the time UFO research groups picked it up in the 1970s, Byrd had turned into a symbol of forbidden discovery. The myth's endurance shows how the continent's silence invites imagination. Where data ends, stories rush in. Modern analysis has effectively debunked the supernatural claims. Flight logs from Operation Highjump and subsequent missions confirm routine survey patterns, not secret passages. Aerial photographs show only ice and mountain ridges. The Valley of Warmth exists in part, but as geothermal oases, not gateways to another world. Even so, the persistence of the tale has had unexpected consequences. It drew attention to the very real mysteries of Antarctica's interior, encouraging new generations of scientists to look deeper. The myth also intertwines with genuine historical ambiguities. Several of Byrd's reports and personal letters did vanish during archival reorganizations in the 1960s. Whether lost, misfiled, or destroyed, their absence created the perfect void for speculation. Declassified materials later filled some of the gaps, confirming that equipment failures and weather accounted for the missing radio contact. Still, the combination of missing documents and unusual statements made Byrd a permanent figure in the literature of the unexplained. For the researchers who study this period, the enduring fascination lies not in proving the diary true or false, but in understanding why it exists at all. Human imagination seems drawn to the idea of hidden worlds, especially beneath or beyond the poles. The geographical extremes mirror psychological ones, the unseen, the unreachable, the place where reason ends. In that sense, the legend of Byrd's Warm Valley belongs less to history than to collective dreaming, a parable about the limits of exploration. Meanwhile, the real Antarctica continued to yield data far stranger than fiction. As declassification expanded through the 1990s, scientists gained access to magnetograms and seismic profiles gathered during those early flights. They revealed no lost civilizations, but they did expose vast subglacial basins, later confirmed as lakes and melt zones. The imagery showed thermal gradients that could sustain microbial ecosystems, validating the core of what Byrd had observed, areas where heat and life coexist beneath miles of ice. Even the myths themselves have value. Anthropologists now treat the Byrd diary as an artifact of cultural history, evidence of how 20th century societies processed uncertainty. The same era that split the atom and mapped DNA also produced fantasies of hollow earths and ancient warnings. Both impulses came from the same source, the desire to find coherence in a universe that kept expanding beyond comprehension. In recent years, forensic linguistics has been applied to the diary text, revealing stylistic fingerprints of post-war pulp authors. The vocabulary and phrasing align with early 1950s magazines about flying saucers, not with Byrd's documented writing style. The analysis effectively ends the debate about authorship, but not about meaning. To many, the story's endurance underscores how Antarctica functions as a mirror for human belief, a blank continent reflecting whatever hopes or fears we project onto it. Still, a few threads of genuine intrigue remain. Among the surviving communications logs, one message mentions anomalous temperature inversion and visibility 10 miles. Terrain appears irregular. Though likely referring to meteorological phenomena, this single phrase continues to inspire speculation that Byrd saw something inexplicable. Meteorologists explain it as a mirage effect caused by layers of warm and cold air bending light, an illusion common in polar regions that can make distant mountains appear as floating islands. Such inversions can even magnify features hundreds of kilometers away, perhaps creating the impression of a green valley amid the ice. What the radar could not verify, imagination supplied. Decades later, satellite data finally confirmed the presence of geothermal upwellings beneath the same region. The physical explanation, volcanic heat trapped by thick ice, arrived long after the myth had taken root. By then, the lost diary had become part of Antarctica's cultural geology, layered alongside its fossils and meteorites as another kind of artifact. The truth that remains is quieter, but no less profound. Byrd's real contribution was mapping the last great unknown and exposing how fragile human certainty becomes in the face of the infinite white. His flights over the pole gathered measurements that still serve as reference points for modern navigation. The myth that followed him simply dramatized what the data already implied, that Antarctica hides more than we can yet see. Even after every falsehood is stripped away, the echo of his supposed discovery persists as metaphor. The warm valley exists, if not in geography, then in the collective mind, the image of a hidden refuge beneath desolation, a reminder that mystery is not something found but something felt. And as new generations of explorers lift their drones and sensors into that same sky, they find that the ice continues to distort compass needles and reflect light in impossible ways. The instruments hum, the data streams, and beneath it all lingers the same quiet question that haunted Byrd: what lies beyond the horizon we can measure? Whatever the answer, the next set of anomalies would pull that question back toward the surface. Satellite images showing geometric shadows on the snow, shapes that seemed almost architectural, stirring a new wave of curiosity about what waits beneath the endless white. When the first satellites began photographing the Antarctic interior, no one expected the images to become objects of myth. They were meant for cartography, high-resolution mosaics of the ice sheet to track climate change and glacial movement. Yet soon after those pictures became public, they ignited a different kind of curiosity. Amid the endless folds of white, a few patterns appeared that were difficult to categorize. Angled shadows, geometric ridges, and symmetrical peaks seemed to interrupt the natural chaos of snow. In an age already hungry for mystery, those shapes began to look less geological and more deliberate. The most famous image emerged from Queen Maud Land, captured by a NASA satellite in 2012. Against the vast plain, a single triangular mountain rose from the ice, its edges sharp and clean. Internet forums quickly labeled it the Antarctic Pyramid. At first glance it appeared artificial, an object too perfect for nature. Theories multiplied overnight: a forgotten civilization, a buried structure exposed by melting ice, proof that Antarctica had once hosted intelligent life. The photograph travelled faster than the researchers who could explain it. Geologists recognized the formation immediately. It was a nunatak, a peak of bedrock protruding through the glacier, its symmetry carved not by architects, but by wind erosion and freeze-thaw cycles. When snow and ice retreat, these peaks stand isolated like monuments, their sides polished into geometric simplicity. Thousands exist across the continent, though most lack the convenient alignment of this one. The angle of the sunlight and the perspective of the satellite did the rest, turning geology into architecture. Even so, the image stuck in the collective imagination. That single photograph inspired years of amateur analysis. Some observers overlaid coordinate grids, claiming alignment with the pyramids of Giza. Others calculated proportions, searching for intentional design. In each case, the data itself never lied. It was the human eye that supplied the illusion. Glaciologists patiently demonstrated how fracturing ice and katabatic winds could shape ridges into near-perfect triangles. Yet explanations seldom travel as far as wonder. Beyond that first image, other shapes emerged. In 2018, a European satellite recorded a series of polygonal patterns etched into the surface near the Ross ice shelf. Each cell stretched several hundred meters across, forming what appeared to be a vast tessellation. To the untrained observer, it resembled paving stones or foundations. To scientists, it was something else entirely: ice polygons, a phenomenon caused by contraction during extreme cold. As the surface freezes and shrinks, it fractures along tension lines, producing hexagonal patterns identical to those seen in permafrost on Mars. What looked like design was simply physics repeating itself. The distinction matters less than the fascination it inspired. Every time the Antarctic summer exposes new ground, satellites capture shapes that seem too precise for chance: straight edges, arcs, parallel ridges. Sometimes they are crevasses filled with shadow, other times they are buried mountain ridges or snow dunes sculpted by prevailing winds. Yet each image finds an audience eager to believe that someone or something was there before us. That belief finds roots in a longer history. Since the discovery of the Piri Race map, speculation about ancient Antarctic civilizations has never completely faded. The modern eye, conditioned by satellites instead of parchment, sees digital echoes of the same dream. Patterns become blueprints, erosion becomes evidence. For archaeologists, these claims can be exhausted. Every field season, new rumours arise. An entrance spotted in a cliff face, a building beneath transparent ice, a runway carved into snow. Closer inspection always reveals natural origins, lava tubes, ice caves, or optical illusions created by low-angle light. But the recurrence of such sightings points to something deeper, our need to find intention in randomness, to populate the emptiest place on Earth with meaning. That human instinct met its technological counterpart when algorithms began scanning Antarctica for geological anomalies. Artificial intelligence trained on satellite data started flagging features of unusual symmetry. Many turned out to be perfectly ordinary, but a few continue to puzzle even experts. One example is a series of linear ridges under the western ice sheet, hundreds of kilometers long and uniformly spaced. Their cores may be basal melting and refreezing, a rhythmic pattern formed as the glacier pulses toward the sea. To a geologist, they represent climate oscillations frozen into shape. To others, they look suspiciously like design. The same duality defines nearly every discovery in this landscape. Natural pattern or deliberate construction. The question hovers between disciplines. When sonar mapping revealed vast subglacial trenches forming concentric circles, speculation leapt again toward architecture. Subsequent analysis showed there were ring faults, scars from ancient volcanic eruptions beneath the ice. Nature, it seems, has an engineer's precision when given enough time. Yet even when science demystifies the image, fascination persists because the photographs themselves are beautiful. Vast plains of shadow and light, forming shapes the human brain cannot help but interpret. Each new satellite pass over the polar plateau delivers more of these illusions, and with them more stories. The persistence of the Antarctic structures myth has not been entirely negative. In some cases, public curiosity has directed attention and funding toward legitimate research. High-resolution radar surveys now map the bedrock beneath the ice in exquisite detail, revealing mountains, canyons, and buried volcanic systems. The more accurately we measure, the more complex the landscape becomes. The so-called pyramids and polygons may be misinterpretations, but they point to a genuine truth. Beneath the ice lies a topography as intricate as any continental surface, shaped by forces we still struggle to model. Occasionally, new data introduces a sliver of legitimate mystery. In 2019, radar detected an angular void beneath several hundred meters of ice near the Shackleton Range. Its walls reflected signals differently than the surrounding rock, suggesting a cavity filled with sediment rather than solid ice. Drilling hasn't yet reached it, so its nature remains uncertain. Most likely it's a buried lava tube or an ancient melt channel. But even among scientists, curiosity lingers. When instruments touch something unknown in a place already defined by absence, the mind drifts naturally towards story. The scientific consensus, though, remains clear. There are no verified artificial structures beneath Antarctica's ice. What exists are natural formations, shaped into geometric coincidence by wind, temperature, and pressure. Still, the myth endures not because people reject science, but because the images themselves seem to invite it. The human brain is wired for recognition. It seeks patterns the way lungs seek air. In a continent of featureless white, even a triangle becomes a monument. There's also the element of timing. As climate change accelerates melting along the coasts, more of these shapes appear in photographs each year. The retreating ice reveals ridges and peaks unseen for tens of thousands of years. Some indeed bear uncanny regularity, striations left by ancient glaciers that moved with mechanical precision. The more the ice melts, the more the planet itself begins to look engineered. For those who work in Antarctic geology, the challenge is to navigate between dismissal and wonder. It is easy to laugh at viral images, harder to maintain curiosity while resisting fantasy. Many researchers privately admit that standing before a mountain so symmetrical it looks designed, they feel the same shiver as any believer. Knowledge doesn't always silence mystery. Sometimes it deepens it. Each new expedition refines the map, and with it, the story. The so-called pyramid is now catalogued as part of the Ellsworth Mountains, a relic of Jurassic tectonics. The polygon fields near Ross Sea are monitored for permafrost studies. The angular void near Shackleton remains unvisited, awaiting a future drill team. Nothing supernatural, yet each detail contributes to a portrait of a continent more dynamic and surprising than myth ever imagined. When the satellite passes again, photographing the same region under a different sun, the shadows change and the structures vanish, proving once more that light itself is the sculptor of Antarctic mystery. What yesterday looked like a city becomes today's glacier ridge. What tomorrow's radar sees will birth new shapes, new stories. In the end, the fascination with geometry on the ice reveals less about Antarctica than about ourselves. We look into the white void and project the outlines of intention because true emptiness is intolerable. The pyramids of snow, the corridors of shadow, the phantom runways, all are reflections of human imagination, refracted through the world's purest mirror. And yet, beneath those illusions, real warmth occasionally stirs. The same satellites that capture the false patterns also record faint thermal anomalies, patches where heat leaks upward from the bedrock, hinting at times when the ice itself withdrew and life returned. The next wave of discoveries will come not from images of the surface, but from cores that tell of climates so warm that palm trees grew where glaciers now rule. Those warm intervals, periodic and violent, mark the rhythm of the continent's heartbeat, proof that beneath the perfection of ice geometry lies a history of fire and bloom waiting to be read. In the depths of the Antarctic ice, time is measured not in centuries, but in layers. Each snowfall compresses into a page of the planet's history. Dust, salt, pollen, ash, and trapped air accumulating into an unbroken narrative that reaches back nearly 1 million years. When scientists extract an ice core, they are, in essence, drilling through time itself. The air bubbles suspended within that translucent column are the same air once breathed by mammoths, forests, and early humans. What they reveal is both scientific and almost elegiac, a record of Earth's breath written in frost. The first cores drilled during the 1960s were primitive, no thicker than a wrist. Yet even those early samples told a profound story. Within the trapped gases, researchers detected variations in carbon dioxide and methane synchronized with temperature changes recorded by isotopes of oxygen and hydrogen. The correlation was unmistakable. As greenhouse gases rose, so did warmth. When they fell, ice spread. The cycles repeated with mathematical precision, roughly every 100,000 years, reflecting the slow dance of Earth's orbit around the Sun. Antarctica's ice became the planet's pulse monitor, steady and unflinching. As techniques improved, the cores grew longer, reaching deeper and older strata. By the 1990s, teams at Vostok station had recovered ice from 420,000 years ago, capturing 4 complete glacial interglacial cycles. Each transition told of catastrophe, followed by renewal, warmth melting into cold, ecosystems collapsing and re-emerging. The most recent, marking the end of the last ice age about 11,700 years ago, coincided with the rise of agriculture and the birth of civilization. Humanity's entire history fits neatly into the thin upper crust of that cylinder, just a sliver atop a frozen mountain of time. Deeper drilling at Dome C extended the record even further, to nearly 800,000 years, and a new European project aims to double that again. What these cores reveal is not a stable planet, but one that oscillates, breathing in and out over millennia. The current rise in greenhouse gases appears faster and higher than anything seen in that entire span. For climatologists, the ice is not simply a relic, it is a warning inscribed in chemistry. Each bubble whispers what happens when equilibrium breaks. Beyond temperature and gases, The cores contain microscopic traces of distant events. Layers streaked with volcanic ash mark eruptions in Indonesia, Iceland, and the Andes. Spikes of beryllium-10 hint at solar storms that once bombarded the atmosphere. In some layers, tiny glass beads record meteor impacts, linking cosmic collisions to shifts in climate. The ice functions as a planetary archive, integrating sky and Earth into a single continuous record. Its precision astonishes. Scientists can date certain layers to within a decade, matching them to tree rings or archaeological strata elsewhere in the world. One of the most intriguing findings came from a narrow grey band discovered about 12,900 years ago, a layer rich in platinum, soot, and microscopic spherules. Some researchers interpret it as evidence of a comet impact, one that may have triggered the abrupt cooling known as the Younger Dryas. Others attribute it to volcanic activity. Whatever the cause, the chemical fingerprint appears in cores from both hemispheres, suggesting a global event. In Antarctica, that same layer marks a sudden shift. The ice thickens, dust increases, and temperatures plummet almost overnight. If it truly was an impact, it shows how quickly climate can turn from stability to chaos. Even within such cataclysmic layers, traces of life persist. Bacterial DNA, fossilized pollen, and tiny fragments of algae lie suspended between crystals, carried there by ancient winds. By analyzing their composition, scientists can reconstruct ecosystems far beyond the poles, tropical forests in South America, savannas in Africa, deserts expanding and retreating with each pulse of climate. Antarctica's ice, though distant, records the world entire. What astonishes researchers most is the periodic warmth hidden in the record. Several times in the past million years, the continent partially thawed, revealing lakes and wetlands along its coasts. During the mid-Miocene, roughly 15 million years ago, temperatures were high enough for trees to grow within sight of the South Pole. Even more recently, sediments beneath the ice show traces of moss and diatoms from about 3 million years ago. These warm intervals coincide with CO2 levels similar to those measured today, implying that the past may soon repeat itself. The difference is speed. Our changes unfold in centuries, not millennia. Yet these ancient interludes were not disasters. They were transformations. Where glaciers retreated, ecosystems blossomed. Rivers carved valleys now hidden beneath kilometers of ice, and life adapted to the extremes. The fossil record proves that warmth once returned to Antarctica naturally, and that when it did so in bursts, rapid transitions, lasting mere centuries before stabilizing. The challenge for modern humanity is that such transitions, once survivable for microbes and moss, now threaten entire civilizations. Even as the ice warns, it also teaches resilience. The microbes found within some cores remain viable despite hundreds of thousands of years in dormancy. When revived under laboratory conditions, they metabolize again, proof that life's capacity for endurance exceeds imagination. If bacteria can survive deep freeze epochs, then the biosphere as a whole may be more adaptable than we fear, but that resilience comes at a cost. Adaptation follows loss. Among the most poignant revelations are the air bubbles themselves. When scientists analyze them, they can reconstruct the exact composition of ancient atmospheres. How much oxygen, nitrogen, carbon dioxide, and trace gases filled the skies when early humans lit their first fires. The air in those bubbles is breathable. Some researchers have described opening a core and inhaling faint traces of that trapped atmosphere, the literal breath of prehistory. It's a moment that collapses time, to breathe what the world once was, before the Anthropocene began. Each core, once removed from the drill, is sliced into segments and stored in temperature-controlled vaults across the world. The pieces are handled like manuscripts, catalogued and preserved for future study. To the scientists who work among them, the freezers feel like libraries, a cathedral of silence, where time itself is shelved, And in that frozen archive lies a message as urgent as any prophecy. The Earth's rhythms are patient but not infinite. The cores also reveal a subtle but recurring anomaly, minute oscillations in carbon isotopes that don't match known orbital cycles. Some attribute these to internal climate feedbacks, others suspect they mark volcanic pulses or even magnetic field fluctuations. Whatever the cause, the pattern suggests that Earth's climate is not only a product of solar input, but of processes still poorly understood, perhaps deep within the planet itself. Each new layer of ice both clarifies and complicates the story, adding dimension to our understanding of interconnected systems that stretch from core to cosmos. There's poetry in the method. The drilling rigs hum, the auger descends, and the core rises slowly from the depths, an unbroken column of frozen memory. When the final segment emerges, glittering under floodlights, it carries within it storms, droughts, extinctions, and rebirths, all compressed into silence. It's the most fragile object on Earth, and the most revealing. The data derived from these cylinders now underpin every climate model, every projection of future warming. Antarctica, by preserving its own past, may be our last hope for understanding what comes next. But the ice hides one final paradox. As it melts, it releases not only water, but information. Meltwater streams carry ancient particles into the ocean, seeding new ecosystems while erasing their own record. The very process of revelation becomes an act of loss. Scientists race to extract the oldest cores before rising temperatures destroy them, aware that each summer shortens the archive. In a sense, Antarctica is speaking faster now. The melt accelerates, the records grow shorter, and each data point becomes both warning and elegy. What began as frozen history is turning into prophecy, a story written not for the past, but for the future. And as those ice cores reach their final depths, researchers are beginning to notice faint chemical traces that precede even the oldest human record, hints of climates so warm and lush that continents lay arranged differently, seas higher, and life abundant where none should have been. To follow those traces will mean drilling beyond history into prehistory itself, into a time when Antarctica was not a memory of cold but a cradle of life. That pursuit, the search for the green Antarctica beneath the white, will lead directly to the next stage of discovery, a revelation that challenges the very boundaries of time and forces humanity to see the frozen continent not as the end of the Earth, but as its beginning. There are moments when science brushes against mythology, not because the data invite it, but because the scale of the revelation exceeds imagination. The discovery that Antarctica was once green, even tropical, belongs to that category. It did not come from legend or speculation, but from quiet layers of sediment extracted from beneath 2 miles of ice, samples so rich in organic matter that their color alone, a deep ochre rather than grey, told scientists they were holding the remains of an ancient forest. The core was drilled from the seafloor of the Amundsen Sea, near Pine Island Bay, in 2019. When researchers examined it under microscopes, they found intact pollen grains, spores, and root networks, preserved so perfectly that cell structures were still visible. Radiometric dating placed them at roughly 90 million years old, in the heart of the Cretaceous period. At that time, dinosaurs roamed Antarctica's coastal plains, and the South Pole basked in months of sunlight each year. What stunned scientists was not merely that forests existed there, it was the kind of forest they revealed. The pollen came from conifers, cycads, and flowering plants typical of temperate rainforests. Chemical analysis of leaf waxes suggested mean annual temperatures around 12 Tulip C, comparable to modern Germany or southern New Zealand. Even in the long polar night, the ecosystem thrived. That implied an atmosphere far richer in carbon dioxide, about 4 times higher than today's levels. The entire planet, not just the poles, was warmer then. Antarctica's greenery was not an anomaly, but a reflection of global equilibrium in a greenhouse world. This finding linked neatly with earlier clues. Coal seams buried under the transantarctic mountains, fossilized tree trunks found near the Byrd Glacier, and impressions of ferns and ginkgo leaves scattered across shale. Each discovery had hinted at warmth, but now the image was complete. Antarctica was not a frozen desert in its infancy. It was a rainforest ringed by rivers, where insects buzzed and large reptiles wandered among trees. Fragments of fossilized wood still retain annual growth rings, evidence of alternating light and darkness through the polar seasons. Some trunks show signs of adaptation, dense tissues for slow metabolism, wide vessels to capture limited light, proof that evolution shaped life even for a sunless half-year. It was a world of constant twilight and rich humidity, where ecosystems adjusted not to heat or cold, but to rhythm. As the Cretaceous ended, that rhythm shattered. Volcanic eruptions in what is now India released enormous quantities of gas into the atmosphere, followed by the asteroid impact at Chicxulub. Within a geological instant, temperatures dropped, photosynthesis faltered, and the forests of Antarctica died. Layers of ash sealed them, and the ice began its slow descent. Yet the continent never forgot its green age. Beneath the glaciers, radar still traces the contours of those fossilized valleys, riverbeds, and deltas frozen in relief, silent cartographies of vanished sunlight. Further drilling beneath the Ross Ice Shelf uncovered sediments even older, dating back more than 100 million years. Their magnetic orientation confirmed that Antarctica once sat closer to the equator, part of Gondwana's vast southern arc. Over millions of years, tectonic drift carried it southward, dragging its forests into darkness. The process was glacial in both senses, so slow that generations of living creatures could adapt as continents shifted beneath them. Among the most surprising finds within those ancient layers are traces of freshwater diatoms, microscopic algae that live in rivers and lakes rather than oceans. Their presence proves that vast inland waterways once covered Antarctica, feeding into coastal deltas. Combined with fossil pollen, these diatoms outline a continent alive with streams, wetlands, and swamps. The topography we imagine as sterile ice fields once echoed with the sound of moving water. To reconstruct that environment, scientists use isotope ratios from oxygen trapped in mineral grains. These measurements act like thermometers frozen in stone. They confirm that polar regions maintained mild temperatures, even during the darkest months, thanks to the insulating effect of dense vegetation and high atmospheric CO2. Forests not only survived, they created their own microclimate, capturing and releasing heat in seasonal cycles. There is something humbling about realizing that Antarctica, which today defines the idea of lifelessness, was once a cradle of abundance. The fossil record tells of insects resembling dragonflies, of primitive birds, of small mammals darting through ferns. In one site near Mount Kirkpatrick, paleontologists uncovered a Jurassic-era amphibian species unknown elsewhere, its bone structure adapted to both land and water. Nearby, plant fossils showed leaves from tree species found in ancient Australia, confirming the continental connection. The land that now divides hemispheres once joined them, knitting the world into a single biosphere. What followed is written in chemistry rather than bone. Around 34 million years ago, global carbon dioxide levels dropped sharply, perhaps due to weathering of newly uplifted mountain chains. Ocean currents shifted, and the Antarctic Circumpolar Current formed, a ring of water isolating the continent from warmer seas. Within less than 1 million years, glaciers spread from the interior to the coast. The forests withered, buried beneath advancing ice. Sediment layers record this transformation in stark contrast, rich organic black suddenly giving way to sterile grey clay, then to frozen silence. Even so, not all life perished. Microbes adapted, finding refuge in the soil and permafrost. Fossil DNA from those horizons shows genetic links to modern extremophiles living in Antarctic lakes today. Evolution did not stop. It slowed, preserving continuity across epochs. It's possible that microbial communities surviving now are direct descendants of species that once thrived beneath towering ferns. The ice preserved their lineage the way amber preserves insects, encased but unbroken. The revelation of a green Antarctica reshaped climate science. It proved that the planet's extremes are reversible, that ice and forest can trade places given enough time. It also redefined the stakes of current warming trends. The levels of carbon dioxide that nurtured ancient forests are approaching modern reality, but at speeds 1,000,000 times faster. The past now serves as both mirror and warning. The world we create may resemble that prehistoric paradise, but at immense ecological cost. Geologists have since identified other intervals of warmth hidden in the record. During the Pliocene about 3 million years ago, global temperatures were 2-3 pole Terce higher than today, and parts of West Antarctica were ice-free. Marine sediments from that era contained shells of plankton species that require open water, implying that the Ross and Amundsen seas were navigable. The sea level stood roughly 20 meters higher, flooding coastlines worldwide. The evidence is unequivocal. The Antarctic ice sheet has collapsed and reformed multiple times in Earth's history. And yet, in all those cycles, one pattern recurs. Life returns. When the ice retreats, mosses colonize the exposed rock. When warmth spreads, ecosystems follow. The fossil pollen from ancient forests reappears in younger layers, suggesting recolonization after each freeze. Nature remembers how to begin again. Today's researchers use these ancient analogues to model future change. By comparing the isotopic signatures of Cretaceous sediments with modern CO2 levels, they can forecast how current warming might reshape global systems. The models indicate that if carbon dioxide surpasses 600 parts per million, the West Antarctic ice sheet could collapse within centuries. What happened naturally over millions of years might now unfold within human time. Still, there is awe amid the anxiety. To uncover a leaf impression perfectly preserved after 90 million years is to touch a moment when the world was utterly different, yet made of the same elements: carbon, water, sunlight, memory. That realization gives the data an almost spiritual weight. The frozen desert, it turns out, is not an end but an intermission. From these revelations rises a final paradox. The more we learn about the living Antarctica of the past, the more we sense how temporary the frozen one may be. The continent has changed before. It will change again. Beneath the glaciers sleep the roots of forests, waiting for light, the spores of mosses, waiting for thaw, the imprints of rivers, waiting for flow. In the geological sense, nothing here is dead, only dormant. And as satellites continue to track the slow melt at the edges, scientists speak softly of déjà vu, that perhaps what we call climate crisis is also the planet's long memory resurfacing, the echo of an age when Antarctica was not a symbol of isolation, but of connection. Every discovery pulled from Antarctica's depths reshapes the human sense of time. The forests revealed its past warmth, but the stones at its edges show something even older, the world before Antarctica existed at all. When you hold one of those rocks chipped from the transantarctic mountains, or lifted from the Lambert Glacier's terminus, you are touching material forged long before there was ice, or mammals, or continents in their current form. Antarctica's geology is a map not only of the planet's movement, but of its endurance, a chain of collisions, fractures, and metamorphoses spanning billions of years. The story begins with Gondwana, the supercontinent that united what are now South America, Africa, India, Australia, and Antarctica. Around 550 million years ago, the landmass stretched across the southern hemisphere, lush and interconnected. The crust that would become Antarctica lay at its heart, a stable shield of ancient granite and metamorphic rock, known today as the East Antarctic Craton. For hundreds of millions of years, it barely moved. Its edges, however, were restless, colliding with volcanic arcs, absorbing fragments of smaller continents and knitting them into a single geologic quilt. Evidence of those collisions lies in bands of rock, like the Ross Oregon, where mountain roots now hidden under ice once rivaled the Himalayas. Tiny crystals of zircon, the most durable mineral on Earth, found within these formations, have been dated to over 4 billion years old, the earliest physical record of Earth's crust. Their survival is a kind of miracle. Each one endured the destruction of multiple worlds, melted and recrystallized again and again, yet still preserves the isotopic signature of its origin. As Gondwana drifted, Antarctica's role changed from tropical basin to polar keystone. Fossils of the Glossopteris tree, discovered across all the southern continents, prove that these lands once shared not just proximity but climate. Then came the slow fracture. About 180 million years ago, rifts opened, magma welled up, and Gondwana split apart. Antarctica tore free, first clinging to Australia, then finally isolating itself entirely. The record of that separation remains etched into the crust, long dike systems filled with basalt, corridors of cooled magma marking the line where continents once joined. Beneath the West Antarctic ice sheet, geophysical imaging has revealed a network of subglacial rift valleys, deep trenches filled with younger volcanic rock. These are scars from that continental breakup, still faintly warm. The heat they release today influences how ice flows above them, lubricating glaciers and feeding subglacial lakes. The continent's geological past continues to shape its frozen present in ways invisible from the surface. Some of the most striking clues come from meteorites recovered along the Transantarctic mountains. Their chemical composition matches rocks found in Africa and India, confirming that these regions once shared the same crustal roots. Antarctica's mountains, though buried in snow, hold the connective tissue of the ancient world. Each sample ties the puzzle back together, proving that continents are not separate entities, but fragments of a single drifting body. As the ice retreated and advanced over epochs, it carried rocks across vast distances, depositing them in moraines and nunataks. Embedded within these erratics are minerals that record temperature and radiation exposure, allowing geologists to reconstruct the exact timing of glacial expansions. Some of these stones have lain exposed to the sky for 500,000 years, enduring without corrosion. Their surfaces act as cosmic calendars, etched by isotopes created when cosmic rays strike them directly. By counting those isotopes, beryllium-10 and aluminum-26, scientists measure how long a rock has rested in sunlight since the ice last released it. In this way, Antarctica's stones tell a story that bridges both geological and cosmic time. What makes these findings more than academic is their precision. When matched with marine sediment cores, they reveal the rhythm of ice ages, the waxing and waning of glaciers tied to subtle changes in Earth's orbit. The rock and the ice speak together. Their combined record shows that the Antarctic ice sheet, though ancient, is not permanent. It has melted and regrown at least 60 times, each cycle erasing and rewriting coastlines across the globe. One of the more haunting chapters of this story concerns the Gamburtsev Mountains, a range hidden entirely beneath the East Antarctic ice sheet. Discovered by radar in the 1950s, they stretch across 1,200 kilometers and rise higher than the Alps, yet no human has ever seen their peaks. Seismic mapping shows that they are not young volcanoes, but ancient roots, formed over 1 billion years ago when continental fragments collided. The mystery is how such sharp relief has survived under ice for so long. Ordinarily, erosion would flatten mountains in tens of millions of years. The only explanation is that ice itself preserved them, freezing them in time, protecting their jagged form like a mold. Geologists describe it as a landscape trapped at the moment of creation. Between the Gamburtsev's peaks lie deep valleys, that may still contain sediments from a time when rivers flowed freely. If ever reached, those sediments could hold the oldest DNA on the continent. For now, they remain sealed under more than a mile of ice, a memory locked within a glacier's grip. Elsewhere, along the coast of Marie Byrd Land, the story is more volatile. There, seismic readings reveal active volcanoes beneath the ice, some as recent. The largest, Mount Erebus, towers above the Ross Sea, its summit a cauldron of molten lava that burns year-round despite the surrounding cold. This paradox, fire within frost, defines Antarctica's geological identity. It is not a continent of stillness, but of suppressed motion. The same tectonic forces that broke Gondwana apart continue to shape its underworld, generating heat that seeps upward, thinning ice, creating the conditions for subglacial lakes. These volcanic regions also emit gases, carbon dioxide, sulfur dioxide, and trace metals that vent into the atmosphere through cracks and melt zones. By analyzing ice cores, scientists can trace volcanic eruptions over hundreds of thousands of years, matching them to global climate fluctuations. Each spike in sulfate concentration marks a pulse of Earth's interior influencing its surface. The cycles of eruption and freeze are interlocked. When volcanoes release enough heat, glaciers melt. When glaciers expand, they suppress volcanic activity by adding pressure. Antarctica thus participates in a geological dialogue between fire and ice, regulating its own balance. Further inland, magnetic mapping has uncovered anomalous crustal blocks, unlike any known elsewhere. Some are dense with iron, others with rare minerals, such as zirconium and thorium. These compositions suggest pieces of proto-continents older than Gondwana, perhaps fragments of even earlier supercontinents, like Rodinia or Columbia. Antarctica, often viewed as a frozen void, may in fact preserve the missing chapters of planetary assembly, the connective tissue between epochs, long erased elsewhere by erosion and tectonic recycling. What makes this record so profound is that it cannot be falsified by theory. It is written in atoms. Each isotope, each mineral grain, each alignment of crystals speaks a language of pressure and heat that predates human comprehension. The rocks tell of oceans closing and reopening, of mountains rising and collapsing, of the slow pulse of continental drift that over billions of years transformed the planet into a habitable sphere. Standing before the exposed strata of a Nunatak, scientists often describe a sense of vertigo. Beneath their boots lie layers that witnessed the birth of oxygen in the atmosphere, the first flowering of complex life, the mass extinctions that reshaped evolution itself. To touch that stone is to feel the weight of time condensed into silence. The ice above protects it, but it also hides it, each snowfall another veil over the oldest evidence we possess of the Earth's memory. From these findings, one lesson becomes unmistakable. Antarctica is not simply the endpoint of the world's geography, but its archive. It carries within its rocks the prologue of continents, within its ice the chronicles of climate, within its volcanoes the whispers of the planet's core. The frozen surface is only the latest page in a volume still being written. And if those stones and crystals recount the deep past, the next layers of exploration begin to hint at the near future, a world in which the ice retreats again, revealing not only the landscapes of prehistory, but perhaps traces of something newer, something left by human hands when we first reached the edge of the planet and dared to stay. It is easy to imagine Antarctica as untouched, a place where only nature has left its mark. But across the last century, the ice has begun to record another layer of history, our own. Every footprint, every radio transmission, every trace of fuel or smoke becomes part of the continent's expanding archive. Even silence leaves residue. Beneath that veneer of purity lie the relics of human arrival, fragments of expeditions, rusting equipment frozen in place, and the chemical fingerprints of our atmosphere settling over snow. What began as exploration slowly turned into habitation, and habitation, however brief, has its archaeology. The first permanent traces appeared long before satellites or research treaties. Early explorers like Scott and Amundsen built huts of timber and canvas, never intending them to last. Yet the cold preserved them perfectly. Inside Scott's hut at Cape Evans, opened decades later, the smell of seal oil still lingers. Tins of biscuits remain stacked on shelves, their labels legible. Objects abandoned in 1912 survive as if time itself paused the moment the door closed. Scientists now treat these structures as frozen museums, their contents revealing not only the heroism of early exploration, but the fragility of human presence in a place designed to erase it. When nations began establishing research stations in the mid-20th century, those temporary shelters multiplied into small outposts of civilization. Wooden huts gave way to metal domes, diesel generators, and laboratories bristling with antennae. Each installation became a node of human warmth, surrounded by infinite cold. From the air, they resemble constellations scattered across the ice, glowing orange against the blue. Their waste, too, became part of the environment. For decades, barrels of fuel and discarded machinery accumulated around bases, later buried by snow. Some still surface today, preserved in the same way as fossils. Even atmospheric data bears the mark of this era. The ice cores from the 1950s onward show new isotopes: carbon from combustion, lead from gasoline, traces of synthetic compounds, never before present on Earth. These layers form a precise geological timestamp for the Anthropocene, the epoch when human activity began to leave a global signature. Antarctica, distant from factories and cities, functions as the planet's clean slate. What appears there appears everywhere. In the silence of its ice, we can read the sound of industrial civilization spreading across the world. The transition from exploration to scientific occupation reached its peak in 1957-58, during the International Geophysical Year. For the first time, dozens of countries coordinated research across the continent, drilling, mapping, and sharing data. The discoveries were immense: confirmation of the Van Allen radiation belts, the first seismic profiles of the ice sheet, and early evidence of continental drift. Out of that collaboration grew something unprecedented in geopolitics: the Antarctic Treaty of 1959, signed by 12 nations and later joined by many more. It declared the continent a zone of peace, forbidding military activity and guaranteeing freedom of research. In an age defined by nuclear tension, Antarctica became a rare symbol of unity. Still, even peaceful science leaves marks. Stations like McMurdo and Vostok expanded into small towns, complete with power plants, airstrips, and waste systems. The logistics of survival required heavy industry: steel, fuel, plastic. Snow covered much of it, but nothing ever disappeared. Excavations near abandoned bases have uncovered layers of debris, pipes, cables, discarded instruments, encased in ice like modern fossils. Environmental protocols introduced in the 1990s now mandate strict cleanup and waste removal, but earlier decades remain frozen in situ, snapshots of human adaptation to the planet's last frontier. The data collected during that half-century of occupation transformed understanding of Earth's systems. Seismic readings proved that Antarctica's crust is a mosaic of ancient fragments. Gravity measurements revealed the scale of subglacial mountains and valleys, and perhaps most dramatically, instruments stationed there recorded the first hole in the ozone layer in 1985, forcing the world to confront the reach of its pollution. The discovery came from the British Antarctic Survey, whose scientists noticed ultraviolet levels far higher than predicted. Subsequent analysis traced the cause to chlorofluorocarbons, industrial gases accumulating in the stratosphere. Within a decade, global policy changed, banning their use. The atmosphere began to heal. Antarctica, once silent witness, became catalyst. This intersection of human cause and planetary effect continues. As the ice melts, it exposes not only geological layers, but the residue of past expeditions, old campsites, caches of equipment, even human remains. Melting permafrost near the Antarctic Peninsula recently uncovered the skeleton of a long-dead seal, perfectly preserved alongside fragments of cloth and metal, evidence of early sealing expeditions from the 19th century. Each object reminds researchers how quickly exploration turned into exploitation. Whaling stations followed sealing ships, research followed whaling. In less than 2 centuries, Antarctica went from myth to resource to sanctuary. The idea of a human archaeology in such a place seems contradictory, yet archaeologists now map these sites with the same care given to ancient ruins. They record the coordinates of every artifact, from a broken sled runner to a faded photograph pinned to a wall. In this way, the frozen continent tells not only Earth's deep history, but humanity's brief one. Its layers contain both the ash of ancient volcanoes and the soot of modern engines. Future scientists drilling thousands of years from now will find a thin dark band corresponding to our era, a fingerprint of civilization, compressed into millimeters of ice. Even sound leaves traces. Instruments buried at the South Pole capture seismic tremors and low-frequency noise from the ice itself, but also the distant hum of machinery. Within those recordings are echoes of aircraft, generators, and footsteps, mingling with the natural groan of glaciers. In archives, those vibrations form another kind of record, a sonic fossil of human presence at the end of the Earth. Despite regulation, the continent remains vulnerable. Persistent organic pollutants and microplastics now appear in Antarctic snow, carried by wind from continents thousands of kilometers away. Researchers sampling coastal waters have found fragments of synthetic fibers in plankton, proof that even this remotest ecosystem is not isolated. Each year, expeditions bring more technology, more contact, more potential for contamination. The challenge now is not to discover the unknown, but to protect what remains of it. Yet there is a paradox in this tension between intrusion and preservation. Without human exploration, the secrets of Antarctica would remain hidden, but every act of discovery carries a footprint. The treaty's environmental protocols attempt to balance these forces, requiring that scientific benefits outweigh any disturbance. The continent has become a living experiment in restraint, proof that cooperation and curiosity can coexist without conquest. For those who winter there, life follows its own rhythm. Months of darkness dissolve into a single day, stretching half the year. The horizon blurs until sky and ground are indistinguishable. In such isolation, perspective changes. Scientists describe the sensation of time slowing, of existing in a place beyond seasons. The data they gather, wind speed, temperature, cosmic rays, become part of a ritual, a way to measure both the world and the self. The ice listens, and in return it teaches patience. Even communication with the outside world bears symbolic weight. Messages sent from Antarctic stations travel upward to satellites before reaching any other human. Every email, every transmission, every scientific signal leaves the continent by first crossing the void. It is as if the planet insists that all words from its coldest region must ascend before they are heard. When future generations read these records, they will see the 20th century inscribed in them, not as empire or conquest, but as a fleeting collaboration between nations at the edge of existence. They will find evidence of humanity's reach and its restraint, our ability to touch without entirely destroying. The ice will remember the hum of engines, the warmth of lights, and the strange optimism that built laboratories on frozen seas. And perhaps when that ice finally melts again, as it surely will, what remains of those stations will join the fossils of ancient forests and the bones of forgotten species, becoming just another layer in Antarctica's unending chronicle. The continent, indifferent yet observant, will fold our presence into its archive, as it has done with every era before us. Somewhere deep beneath the surface, beneath cables and snow, beneath the echo of turbines, the older stories continue to whisper, those of meteor impacts, shifting poles, and the possibility that Antarctica's past and future are not opposites but reflections of each other. What lies ahead in that mirror may reveal that human history and geological history are not parallel lines, but a single spiral winding toward convergence in the frozen heart of the world. The deeper scientists peer into the frozen continent, the more Antarctica reveals itself as both a memory and a mirror, a place where the planet's hidden systems quietly converge. What once seemed a static wasteland has proven to be a living laboratory of motion, air circling, water rising, magnetic fields pulsing beneath the ice like a heartbeat. Each phenomenon feeds into another, binding the poles to the rest of the Earth in ways only recently understood. The continent may look isolated, but in truth it is the pivot of the entire climate engine. Nowhere is that connection clearer than in the Antarctic circumpolar current, the greatest river on Earth, an oceanic loop that flows unbroken around the continent. It moves 140 million cubic meters of water every second, linking the Atlantic, Pacific, and Indian Oceans into a single global system. Driven by relentless westerly winds, it isolates Antarctica thermally while distributing nutrients that sustain marine life across hemispheres. Scientists call it the conveyor belt of the planet's heartbeat, a circulating artery that regulates temperature and oxygen from pole to pole. Yet this flow also hides a paradox. The same currents that sustain life beyond Antarctica help preserve its desolation. By wrapping the continent in a ring of cold water, they prevent warmer seas from reaching its shores, maintaining the barrier that keeps its glaciers frozen. That barrier has held for roughly 34 million years, but in recent decades, satellites show subtle fractures forming along its outer edge. Warmer water from lower latitudes is now slipping beneath the ice shelves, melting them from below. Each iceberg that carves into the sea is a punctuation mark in the ongoing sentence of change. Glaciologists studying the Thwaites Glacier, often called the Doomsday Glacier, describe it as a linchpin of the West Antarctic ice sheet. Its base rests on bedrock, hundreds of meters below sea level, and warm ocean currents now seep beneath it, thinning the ice from within. If Thwaites were to collapse entirely, global sea levels could rise by more than half a meter. The glacier is retreating faster than any other in the region, losing billions of tons of ice each year. Instruments lowered into its subglacial cavity reveal turbulent waters, rich in salt and heat, eroding the ice like acid. The meltwater then accelerates the process, carving new channels for itself, a feedback loop as elegant as it is terrifying. But even here, the story is not purely one of loss. In those same meltwater plumes, marine biologists have discovered microbial communities, thriving in darkness. They feed on minerals released from the rock, forming biofilms on the underside of the ice. Some metabolize methane, others consume hydrogen sulfide, recycling elements in ways that echo the earliest ecosystems on Earth. Their existence suggests that the end of a glacier can also mark the beginning of new life, a transition rather than extinction. It is as though the continent itself practices resurrection, reshaping every disaster into continuity. The dynamics of this transformation are being tracked through a constellation of satellites that measure gravity, radar, and microwave emissions. GRACE, launched in 2002, has shown that Antarctica loses roughly 150 billion tons of ice per year. ICESat and CryoSat refine those numbers, mapping subtle shifts in elevation to within centimeters. Each dataset becomes a line in the growing narrative of a continent in motion. What emerges from those records is not a picture of sudden collapse, but of acceleration, small, steady changes compounding into irreversible momentum. Scientists reading these signals sense both urgency and awe. The ice is not dying in silence. It is speaking through geometry. Meltwater channels carve fractal networks visible from space, their turquoise lines snaking across the white-like veins. Beneath them, radar reveals rivers kilometers long, flowing under pressure, some connecting subglacial lakes in chains. These waterways surge and drain in cycles, redistributing mass and subtly tilting the entire ice sheet. The Earth responds in kind. As the weight of ice shifts, the crust rebounds upward, altering gravitational fields and even the rotation of the planet. Antarctica, in melting, is literally changing the shape of the world. The interconnection extends into the atmosphere. Every winter as polar night descends, temperatures in the stratosphere plummet, generating the polar vortex, a swirling dome of frigid air that influences weather patterns as far away as the equator. When that vortex weakens or splits, cold air spills northward, triggering harsh winters in North America and Europe. In this way, the rhythm of Antarctic air dictates the moods of continents thousands of kilometers away. The phrase, "what happens in Antarctica doesn't stay in Antarctica," is not a metaphor, but a meteorological fact. And there are deeper resonances still. Beneath the continent's crust, researchers have detected faint geomagnetic anomalies, eddies in the Earth's magnetic field that drift slowly over centuries. The South Magnetic Pole, once firmly anchored on the continent, now migrates northward at nearly 10 kilometers per year. These shifts affect navigation, auroras, and even the radiation belts encircling the planet. Some scientists suspect the movement reflects turbulence in the planet's outer core, liquid iron convecting beneath our feet. If so, Antarctica's magnetic whispers are not local disturbances, but surface echoes of the planet's molten heart. In 2020, seismic instruments, buried under the ice, captured low-frequency vibrations that repeated every few hours, as if the continent itself were breathing. At first, they seemed random, but analysis revealed a pattern corresponding to tides beneath the Ross Ice Shelf. As the ocean rises and falls, it flexes the floating ice like a massive diaphragm, creating rhythmic tremors that travel for hundreds of kilometers. The planet's largest glacier, it turns out, hums in tune with the sea. The human relationship with this hidden symphony is complex. On one hand, researchers race to decode the signals, seeking to predict sea level rise and climate thresholds. On the other, they find themselves confronting a scale that defies control. The numbers are too vast, the feedback loops too intricate. Many describe a sense of humility verging on reverence, a recognition that the planet's processes will continue long after human calculations end. At the South Pole Observatory, scientists have monitored carbon dioxide levels since 19. To read them is to feel the planet thinking in cycles beyond comprehension. The paradox deepens when one realizes that Antarctica, though remote, is also the best place to look outward into the cosmos. The air above it is so clear, so dry, that radio telescopes at the South Pole detect signals from the dawn of the universe. Experiments like BICEP and IceCube study cosmic background radiation and neutrinos, subatomic particles that pass through matter as if it were air. Buried sensors have recorded neutrinos traveling upward through the Earth, their trajectories traced to distant galaxies. Thus, the same ice that holds the planet's climate memory also serves as a lens through which we glimpse creation itself. Everything converges in that duality, the frozen record of the past and the transparent window to the beginning. When scientists stand under the aurora australis, their instruments glowing faintly in the polar night, they are simultaneously studying the smallest molecules of life and the largest structures of the universe. Antarctica unites extremes that elsewhere would seem incompatible: death and genesis, silence and revelation, stasis and movement. Even the wind participates in this paradox. Moving across thousands of kilometers of ice, it scours everything down to the atomic level, polishing stones into spheres, erasing footprints within hours. Yet in doing so, it preserves the surface from further erosion, sealing it under a veneer of permanence. The same force that erases also protects. The landscape becomes both ephemeral and eternal, renewed with every storm. For humanity, the meaning of these discoveries is still unfolding. Antarctica has become less a frontier to conquer than a mirror in which to confront our collective reflection. Its ice tells us who we have been and hints at what we might become if we continue to ignore its warnings. The melting glaciers speak of imbalance, but they also demonstrate resilience, a planet continually reconfiguring itself toward equilibrium. Some scientists call the continent the planet's conscience. It records every act, forgives nothing, and yet offers guidance through evidence. To study it is to participate in a dialogue older than civilization, a conversation between life and the forces that make life possible. And as that dialogue deepens, humanity begins to realize that the mysteries of Antarctica are not only geological or climatic, they are existential. The continent reflects the fragility of every system we depend upon, its shifting currents, its magnetic fields, its breath of carbon and wind remind us that the world is not stable ground, but a living organism perpetually transforming. For now, the research continues. Satellites circling, sensors humming, ice sheets carving into luminous blue fragments. Each piece that drifts into the sea carries within it a record of the past million years, a memory set free to travel the world. When those waters eventually reach distant shores, they will deliver that message wordlessly, that the ice still moves, the planet still breathes, and the story of Antarctica is the story of Earth itself, still unfolding beneath our feet. The story of Antarctica has always balanced between science and imagination, between what is measured and what is intuited. Yet, as the 21st century deepens, a new dimension enters the record, one that fuses the physical and the psychological. For decades, the continent has been a mirror for the planet. Now it becomes a mirror for us. The data reveal not only environmental change, but something more human, the way knowledge itself evolves when faced with mystery. Every expedition, every signal from the ice, seems to circle back to the same quiet realization that we are not simply observing the Earth, we are part of its unfolding experiment. Much of that realization has emerged through the strange intersection of physics and biology taking shape beneath the ice. The Ice Cube Neutrino Observatory, buried more than 2 kilometers under the South Pole, listens not for sound but for flashes of light invisible to the human eye. When a neutrino, a particle so small it passes through entire planets unhindered, collides with an atom inside the ice, it releases a blue photon. Thousands of sensors capture those glimmers, reconstructing the paths of particles that have traveled from distant galaxies, supernovae, and perhaps the edges of black holes. It is astronomy without telescopes, using the Earth itself as the detector. The irony is poetic. In the coldest, most remote place on the planet, scientists are mapping the hottest events in the universe. These measurements confirm that Antarctica, far from isolated, is threaded into cosmic fabric. Each neutrino arriving from deep space passes through the planet's core before emerging in the ice, turning the continent into a receiving surface for messages older than time. The scale collapses. Cosmic and terrestrial history share the same coordinates. It is humbling to realize that particles from an exploding star, millions of light years away, now rest inside the same ice that holds the memory of ancient forests. Every flake of snow that falls here is touched by starlight in ways no mythology ever dared imagine. And yet, while the instruments gaze outward, another set of sensors listens inward to the vibrations of the ice, to the hum of the planet. These infrasound detectors pick up frequencies below human hearing, the groaning of glaciers, the pulse of storms, even the resonances of earthquakes transmitted through the crust. When sped up to audible range, Antarctica sings. The recordings sound like breath, like whale song stretched across centuries. Scientists use them to map internal structures of the ice sheet, but many admit that the sound itself evokes something beyond data, an awareness of the planet as living architecture. This sense of living presence deepens when technology encounters unexpected anomalies. In 2016, the IceCube Array registered a handful of upward-moving neutrinos, events that appeared to originate from within the Earth rather than from space. The discovery triggered both excitement and skepticism. Perhaps the detections were misinterpreted, or perhaps they indicated exotic physics beyond current models. Papers multiplied, Debates filled conferences. For the public, it became another invitation to myth, proof, some said, of hidden reactors, secret experiments, or even gateways beneath the pole. For scientists, the mystery was subtler, the reminder that the universe still reserves surprises, even in its smallest particles. Antarctica's allure lies precisely in that tension between explanation and wonder. Its ice behaves like a lens, through which uncertainty refracts. Each time an anomaly arises, imagination rushes in to fill the void, just as light fills darkness. That human impulse, half curiosity, half longing, drives the greatest discoveries as much as it fuels myths. Parallel to these cosmic revelations, biologists continue to probe the continent's inner ecosystems. Recent expeditions, drilling through 1/2 kilometre of ice into Lake Mercer, discovered living organisms in what should have been sterile blackness. Tiny crustaceans, worm-like invertebrates, and microbial mats thrived in the water. Chemical analysis showed active metabolism, meaning the ecosystem had been sealed away for millennia, yet continued cycling carbon and nitrogen. If life can persist here without sunlight, at sub-zero temperatures, under immense pressure, then the possibility of similar life on Europa or Enceladus becomes not fantasy but expectation. The analogy is unavoidable: Antarctica as rehearsal for extraterrestrial biology. Those samples from Mercer, Whillans, and Vostok have also begun rewriting evolutionary assumptions. DNA sequencing shows lineages branching from common ancestors shared with marine species, implying that these organisms were trapped when the continent froze and adapted ever since. Over millions of years, isolation turned them into biological time capsules. Studying them is like opening a direct portal into pre-ice ecosystems, revealing how life responds when entire climates disappear. Evolution, it turns out, can proceed even in stasis. The parallels between the deep biosphere and the cosmos are not lost on researchers. Both realms, subglacial and interstellar, exist beyond human perception, yet both whisper traces that technology can now translate. In one, we study life surviving without sun. In the other, light traveling without life. Between them lies a metaphor for our own condition: persistence in darkness, meaning drawn from silence. Beyond laboratories, the psychological dimension of Antarctica continues to expand. Prolonged isolation in research stations produces effects that mirror the continent's physical extremes. Months without daylight alter circadian rhythms. The vast whiteness erases depth perception and time. Psychologists call it the Antarctic effect, a blend of sensory deprivation and heightened introspection. Crews report vivid dreams, emotional oscillations, and an acute sense of fragility. Yet within that vulnerability often arises an unexpected calm, a feeling of connection to something larger than the self. It is as if the ice, by stripping away all distraction, reveals consciousness itself as a natural phenomenon, another climate of the Earth. Even communication with home follows a rhythm dictated by space and weather. Storms interrupt satellite links. Messages arrive delayed, fragmented. Scientists describe a peculiar intimacy in this distance. The awareness that every word they send must travel through layers of atmosphere, radiation, and cold before reaching another human being. Over time, that journey imbues language with weight. In diaries, many compare the experience to speaking across centuries, as though their messages were meant for readers yet unborn. In this way, the Antarctic research community becomes a microcosm of future humanity, small, cooperative, dependent on renewable energy, bound by shared purpose. Solar panels and wind turbines now power many stations, reducing diesel use. Waste is compacted and shipped out to avoid pollution. The continent has become a prototype for sustainable living in extreme conditions, a model that may one day guide survival beyond Earth. When astronauts train for Mars, they study Antarctic logistics. When engineers design habitats for frozen moons, they borrow its principles of insulation and recycling. The coldest place on Earth is teaching us how to endure elsewhere. Yet the deeper meaning of these efforts may be philosophical rather than technological. The continent's very hostility forces collaboration. Its isolation erases borders. Within the treaty framework, nations that compete elsewhere share data freely here. The result is a kind of global consciousness in miniature, a reminder that cooperation, not competition, is the natural response to shared vulnerability. Some scholars now speak of Antarctic ethics, an emerging philosophy grounded in humility, restraint, and interdependence. It asks not what we can take from the planet, but what we owe to it. At the heart of this ethic lies a single fact. Everything in Antarctica is connected through feedback, ice, ocean, wind, life, magnetism. A change in one reverberates through all. The same principle applies to civilization. Our emissions alter the ice alters sea levels, the sea alters our cities, the continent becomes a moral mirror showing cause and consequence in perfect clarity. And still, the mysteries persist. Beneath kilometers of ice, seismic instruments occasionally detect resonances too regular to be random, deep rhythmic signals whose origins remain uncertain. Some may be water sloshing through cavities, others tectonic tremors amplified by ice. Yet, among the data, patterns emerge that resemble pulses, beats spaced almost evenly, as if the glacier itself possessed a slow planetary heart. No one claims more than coincidence, but the image lingers, a continent breathing beneath its frozen skin. Perhaps that is the final lesson of these modern discoveries, that Antarctica is not static matter, but process, not silence, but rhythm. From neutrinos to microbes, from tides to thought, everything here participates in cycles of emergence and return. Human beings, by entering this environment, become part of that pattern. The instruments we bury in the ice measure not only the world's behavior, but our own place within it. And so the story bends back toward mystery. The same continent that preserves the past and forecasts the future also reflects the present, reminding us that observation changes what is observed. Each experiment, each core, each recording is an act of connection, a handshake across epochs. The more precisely we measure, the more we realize how deeply entangled we already are. In the end, the true wonder of Antarctica may not be its extremes, but its unity, the way every element, from starlight to bacteria, from human breath to glacial drift, converges into a single, continuous system. The continent shows us what the planet looks like when boundaries dissolve. It is both laboratory and cathedral, both mirror and seed, and within its endless white lies the quiet revelation that the universe, like the ice, is not empty after all, it is full, waiting only for the patience to listen. There comes a point when data alone cannot contain the scale of what Antarctica represents. The numbers, temperatures, isotopes, volumes of meltwater describe phenomena but not meaning. To understand why this continent has always captivated the human imagination, one must follow the invisible thread that links ancient myth with modern measurement, intuition with proof. Even as satellites map its every curve, Antarctica remains a canvas for the oldest human instinct, the search for origins. For centuries before its discovery, cartographers drew Terra Australis Incognita at the bottom of their maps, a vast balancing land they believed must exist to counterweight the continents of the north. It was speculation rooted in symmetry rather than observation, yet it proved astonishingly prophetic. When the first explorers reached the icy coasts in the 19th century, they found the imagined continent real, though far stranger than anyone expected. What began as geometric theory evolved into geography, and what was once legend became landscape. That transformation continues still. Antarctica constantly shifts between concept and reality, never wholly one or the other. The continent's dual identity, imagined and tangible, makes it the perfect site for humanity's unresolved questions. Every civilization has projected its own desires onto the pole. Medieval thinkers saw it as the edge of creation. Enlightenment scholars envisioned a world of perfect geometry hidden beneath the ice. 20th century myths turned it into the stage for lost civilizations and alien ruins. Now, 21st century science replaces those myths with subtler wonders: microbes surviving without sunlight, neutrinos passing through Earth, fossils of rainforests entombed under glaciers. The mystery never vanishes, it changes dialects. Recent advances in satellite imaging have revealed structures in the snow that seem to echo those old cartographic fantasies: rings, lines, and patterns sprawling across the ice. Most have natural explanations: wind-scoured ridges, buried crevasses, but a few continue to resist full classification. Some appear and disappear seasonally, suggesting dynamic subsurface processes rather than static forms. When radar penetrates deeper, it finds voids where ice meets rock, cavities stretching for kilometers, yet stable for thousands of years. They are not temples or cities, but they are architecture of a kind, vaults shaped by geology rather than intention. Archaeologists who once dismissed the idea of human traces in Antarctica now reconsider the possibility of prehistoric visitation. Not civilizations, but perhaps transient contact. Stone tools found on islands near the Antarctic peninsula bear resemblance to early South American artifacts, though the dating remains uncertain. The notion that seafaring peoples might have reached the outskirts of the frozen continent before recorded history no longer seems impossible. Ocean currents would have carried them southward. The question is whether they survived the return. DNA analysis of ancient seals shows occasional genetic exchange with South American populations, implying that at least animals completed that voyage. Whether humans followed remains unproven, but the ocean's memory hints at crossings now lost to time. While archaeologists look for traces of ancient voyages, linguists and mythographers trace Antarctica's shadow through story. In Andean and Polynesian traditions, tales persist of a southern land of endless night, inhabited by spirits of cold and water. Some describe it as the birthplace of storms, others as the final refuge of souls after death. These myths, recorded long before the age of exploration, now read like ancestral intuitions of the pole's existence. They prove that even in absence, the idea of the South exerted gravity on human thought, a reminder that discovery often follows imagination rather than precedes it. In the present, imagination persists in subtler forms. Artists and writers accompany scientific expeditions, translating raw data into sound and color. They record the creaks of glaciers, the rhythm of snowfall, the ultraviolet shimmer of auroras, transforming measurements into metaphor. The results return to the world as films, compositions, and installations, evidence that Antarctica's silence is not empty, but resonant. Each creative act extends the continent's influence beyond geography into culture, turning science back into myth once more. Yet within the laboratories, myth dissolves into precision. Advances in geochronology now allow researchers to reconstruct not only climate, but magnetic history, the times when Earth's poles reversed. Antarctica's rocks hold exquisite records of these flips, frozen snapshots of the planet's magnetic field, locked into iron minerals as they cooled. Over the last 780,000 years, no full reversal has occurred, but smaller excursions leave subtle imprints. The latest sediments suggest another shift may be slowly beginning. If confirmed, compasses worldwide would one day point south instead of north. That change would rewrite navigation, but leave nature unbothered. The Earth's dynamo, buried in molten iron, continues to pulse beyond human timelines. In this sense, Antarctica functions as the planet's magnetic diary, chronicling invisible transformations of its inner heart. Another diary lies in the cosmic dust, constantly falling on the snow. Each year, thousands of tons of extraterrestrial particles settle across the continent, preserved in pristine condition by the cold. When collected and analyzed, they reveal the chemistry of distant stars and asteroids. Some contain amino acids, the building blocks of life. Antarctica thus becomes not only a repository of terrestrial history, but a gathering place for material from across the solar system. Meteorites found here often trace to Mars or the Moon, ejected by impacts long ago. Each fragment carries both alien and familiar signatures, bridging worlds. To hold one is to touch an event that predates the Earth itself. Even the air participates in this cosmic exchange. High-altitude balloons, launched from McMurdo Base, drift around the pole for months, studying cosmic radiation. Their data feed into models of the universe's origin, complementing the ice cube observations deep below. The symmetry is striking. Instruments in the sky and in the ice, one looking outward, the other inward, both converging on the same mystery, how energy becomes matter, how silence becomes form. Amid these vast scales, human presence seems almost microscopic, and yet the human element may be Antarctica's newest geological force. Satellite imagery shows dark streaks on the snow near bases, trails of soot from engines, micro changes in albedo that absorb more sunlight and accelerate local melt. Even the faint warmth of buildings affects surrounding microclimates. Each trace, however small, becomes part of the feedback loop. Scientists monitor their own shadows on the landscape, aware that observation itself alters what is observed. This self-consciousness transforms research into a moral act, turning measurement into mindfulness. Some scientists have begun to describe Antarctica not merely as a place, but as a system of awareness, a planetary sensor attuned to change. Its glaciers respond to atmospheric shifts with immediate precision. Its ice cores record our emissions almost in real time. When humans emit carbon, the signal travels to Antarctica within months, freezing into new layers. The continent becomes an externalized conscience, reflecting every action back to us with mathematical clarity. In that sense, the ice performs a function once reserved for mythic deities, judgment through reflection. The convergence of myth, science, and conscience gives the continent an almost sacred dimension, not in supernatural terms, but in the awareness it demands. Here every movement has consequence, every footprint persists. The silence enforces contemplation. Researchers who spend long winters isolated from the world often speak of a slow transformation, an expansion of attention. The line between observer and observed blurs. They describe the sensation of being watched by the landscape itself, as if the ice possessed memory. Perhaps it does. Crystals growing in snow record vibration, temperature, and light in molecular lattices, physical echoes of passing phenomena. In some sense, the continent is already writing, using matter instead of ink. These overlapping narratives, geological, biological, cosmic, human, intersect most vividly in the aurora. When charged particles from the sun strike the upper atmosphere, they ignite waves of green and violet light that ripple across the polar sky. The phenomenon links solar physics to magnetism, atmosphere to emotion. No photograph conveys its scale. Those who witness it describe a sensation beyond sight, as if standing inside the pulse of the planet. The aurora embodies Antarctica's essence, energy made visible, beauty born from collision. As this century advances, the continent's role in human destiny becomes clearer. It is both warning and guide, mirror and threshold. The melting glaciers reveal archives of life. The deep ice listens to the stars. Our technology, designed to measure, ends up reflecting wonder. What began as exploration becomes communion. In the years ahead, the most important discoveries may not involve fossils or climate data, but understanding itself, the realization that Earth is not a background for human drama, but the drama's author. Antarctica, the last continent discovered, becomes the first to remind us of that truth. The journey that started with ancient maps and myths returns full circle. The imagined land that balanced the world now literally does so, regulating oceans, atmosphere, and perhaps the survival of civilization. Its mysteries remain unsolved not because they are hidden, but because they are ongoing, processes still unfolding beneath the ice. And as long as the wind sweeps across that vast white plain, carrying the faint music of moving glaciers, the story will continue to write itself in a language both scientific and sacred, waiting for us to learn how to read it. There are few places left on Earth where time feels circular, where the present constantly folds into the deep past. Antarctica is one of them. Every discovery there, no matter how modern the technology, ultimately loops back to origins, to how the planet became what it is, to how life began. The deeper we drill, the further back the narrative spirals, until science and prehistory are separated only by vocabulary. What the ice preserves are not just fossils or gases, but the first blueprints of existence itself. Deep within the continent's bedrock, researchers have started to uncover evidence that Antarctica may hold the oldest rocks on Earth. Minerals formed more than 4 billion years ago, when the surface was still molten and continents had yet to form. Tiny zircons, extracted from sediments in East Antarctica, contain isotopic ratios that mark the earliest solid crust known. Their age predates the oldest known rocks in Western Australia and Greenland, suggesting that this frozen land once hosted the cradle of Earth's stability. It is a paradox, the youngest continent hiding the oldest foundation. Those zircon grains also preserve something more intimate, chemical traces of the first water to ever touch the planet's surface. Within their crystal lattices lie isotopic fingerprints of hydrogen and oxygen that indicate contact with liquid water soon after Earth cooled. This finding implies that oceans formed earlier than once believed, within tens of millions of years after the planet's violent birth. If that is true, then Antarctica's minerals contain the memory of the first rainfall, the first sea, the first possibility of life. The trail from stone to cell is faint but continuous. Microfossils discovered in metamorphic rocks along the Prince Charles Mountains suggest that primitive microbial life existed here nearly 3.5 billion years ago. These filamentous structures, embedded in ancient carbon layers, resemble bacterial mats found around modern hydrothermal vents. Chemical analysis confirms biological origins, ratios of carbon isotopes consistent with photosynthesis. It means that even when Antarctica lay near the equator, as part of an early supercontinent, it already hosted life clinging to sunlight. Later, as tectonic drift carried it southward, that life adapted, migrated, or vanished, leaving its molecular ghosts behind. In some of these rocks, scientists find banded iron formations, layered red and grey strata, that record the first great oxygenation of Earth's atmosphere. Around 2.4 billion years ago, cyanobacteria began releasing oxygen as waste, rusting the oceans and turning the planet from a world of metal and methane into one fit for complex life. The bands in Antarctica's rocks mark the pulse of that transition, each layer a breath of an ancient biosphere finding its voice. The oxygen we breathe today was first tested here, locked into iron, sealed under glaciers. Geologists reading this record describe it as humbling. The ice may be temporary, but the continent's memory is eternal. Its stones do not erode. They accumulate meaning. Even after billions of years of pressure, the atoms still tell stories in their isotopic alignments, stories of heat, magnetism, and molecular rebellion. The more precise the instruments become, the more alive the rocks seem, as if whispering the chronicle of every transformation that built the modern world. That continuity between the geological and the biological extends into modern research on extremophiles, microorganisms living in conditions thought impossible for life. In the dry valleys of Antarctica, where humidity approaches zero and UV radiation scorches the surface, bacteria have been found living inside translucent rocks, using tiny films of condensed vapor for survival. Their enzymes repair radiation damage faster than it occurs. Their metabolisms slow to near stasis during darkness, awakening with the first hint of moisture. Genetic sequencing shows adaptations unknown elsewhere, proteins folding at sub-zero temperatures, membranes reinforced by silica. Each mechanism is a record of survival, perfected over millions of years, perhaps echoing strategies that the earliest cells used in the planet's infancy. If such organisms can persist in Antarctica, scientists reason they could exist anywhere ice and rock meet, on Mars, on Europa, even in interstellar dust. The continent has become a testing ground for astrobiology, a preview of cosmic habitability. Every petri dish from the Antarctic soil holds both history and prophecy. When samples are exposed to vacuum and radiation in space laboratories, some survive unaltered, proving that life's chemistry is far tougher than once imagined. What began as the study of microbes becomes a meditation on resilience itself. But resilience in Antarctica is never simple. The same adaptability that allows life to endure also records stress. Sediment cores from the Ross Sea show abrupt collapses in marine biodiversity following climate shifts, extinction events triggered by temperature swings or chemical imbalance. Yet within a few thousand years, the fossil record rebounds with new species. Evolution here operates like breath: contraction, pause, release. Each cycle leaves traces in the calcium shells of plankton and in the DNA of creatures still swimming beneath the ice today. Marine biologists, tracing these genetic lineages, find that Antarctic species often represent living fossils, direct descendants of ancestors thought extinct elsewhere. The icefish, for example, has evolved transparent blood lacking hemoglobin, allowing it to absorb oxygen directly from the cold water. Its genome bears scars of past adaptation, remnants of lost genes turned into regulatory switches. In these mutations lies evidence of the continent's fluctuating past, epochs of warmth, giving way to sudden freezes, forcing life to reinvent itself repeatedly. Even the simplest forms preserve complexity. Viruses isolated from Antarctic lakes display unique protein coats, capable of remaining stable for decades in frozen water. Some carry genetic segments, resembling those of ancient viral families, predating modern multicellular life. Virologists call them molecular fossils, organisms so primitive that studying them feels like reading the preface to evolution. Their existence confirms that viruses, far from parasites, may have been architects of life, exchanging genetic material among early cells and accelerating innovation. The ice, again, serves as both vault and laboratory, keeping these blueprints intact for billions of years. In 2021, scientists analyzing dust trapped within Antarctic snow detected amino acids of extraterrestrial origin, likely delivered by micrometeorites. The composition matched organic molecules found on carbonaceous chondrites, asteroids rich in life's building blocks. Each year, thousands of such particles fall unseen, embedding themselves in the snow, merging cosmic and terrestrial chemistry. The boundary between Earth and universe dissolves quietly in every snowfall. The same molecules that may have seeded life here continue to arrive, unnoticed, like an ongoing dialogue between stars and ice. All these findings converge on a single implication. Antarctica is not merely a passive archive of the planet's story. It is an active participant, a bridge between the material and the cosmic, between past and possibility. The continent demonstrates that creation is not a moment, but a process, a perpetual conversation among elements. Hydrogen meets oxygen, rock meets light, ice meets fire, and from their tension emerges everything that breathes. It is fitting then that many researchers who spend years studying these patterns begin to speak of the continent almost as consciousness itself. They describe how, after months of isolation, their sense of individuality fades. They start perceiving themselves as extensions of the system they measure. The same awareness that connects particle physicists to neutrinos, connects geologists to crystals, biologists to microbes. Antarctica teaches, not through words but through immersion, that observation and existence are mirrors of the same process. When they return north, many describe a lingering effect. Time feels slower, sounds sharper, emotions quieter. Some call it polar clarity, a psychological adaptation that persists long after the expedition ends. It is as if the silence of the ice imprints itself onto the nervous system, rewiring attention. Even in crowded cities, they sense the subtle rhythm of glaciers moving beneath thought. Perhaps this is why every generation rediscovers Antarctica, not only as a frontier of data, but as a frontier of perception. The continent reduces everything to essentials: heat, cold, light, motion. In that reduction lies revelation. The same forces that forged the first minerals and sustained the first cells continue to shape human consciousness. We study the ice to understand climate, but what we really measure is continuity, the unbroken thread between stardust and breath. The oldest zircons, the youngest snowflakes, the microbes suspended between, they all belong to one chronology, written in different scales, and as long as that record endures, it will remind us that our origins were never singular. Life began not once, but endlessly in every place where matter learned to listen. Antarctica is one of those places, still whispering the instructions of creation beneath its frozen veil, waiting for those who can hear in patience rather than haste. The silence that defines Antarctica is not absence, it is accumulation. Each flake of snow, each gust of wind, each buried fossil adds a syllable to a language the planet has spoken for millions of years. Those who study the continent know that every whisper of data hides a larger pattern, a slow conversation between the Earth's surface and its inner machinery. As research deepens, a picture emerges that ties all systems, climate, magnetism, life, and geology, into a single choreography of movement. Antarctica becomes less a location and more an axis around which the story of the planet revolves. Much of that story unfolds in the dark, beneath kilometers of ice. Here, scientists explore a world that behaves like a second ocean, sealed within the first. Using radar, sonar, and seismic waves, they have mapped more than 400 subglacial lakes, connected by an invisible network of rivers that flow despite eternal night. These lakes form under pressure and heat, their liquid maintained by geothermal energy and friction from moving ice. They are as ancient as the continents themselves, locked away since before humans existed. When drilling finally reached them, the water rose to meet the light, releasing bubbles that had been trapped for 500,000 years. Each sample taken from those lakes contained chemical compositions unknown in any surface ecosystem, high concentrations of ammonia, iron, and methane. These are not contaminants, but fuel for unique microbial communities. The organisms feeding on those chemicals mirror those found near volcanic vents deep in the ocean, suggesting a shared ancestry stretching back to the earliest forms of metabolism on Earth. Life here is not an intruder, it is native, shaped by pressure and darkness. When viewed through the lens of deep time, the subglacial lakes act as living fossils, keeping ancient processes alive in their isolation. Lake Vostok remains the largest of these hidden seas, stretching more than 250 kilometers beneath the ice. Drilling into it required decades of engineering to avoid contamination. When samples were finally analyzed, they revealed thousands of DNA sequences, many belonging to previously unknown species. Some matched microorganisms adapted to extreme heat, others to deep-sea pressure, implying that the lake's ecology is a hybrid of elements from both fire and ice. The irony is profound. The coldest place on Earth shelters organisms evolved for warmth, proving that nature does not obey human categories. Even more astonishing are the findings from Lake Whillans and Mercer, smaller but shallower bodies of water discovered beneath the Ross ice shelf. The sediments in these lakes contain microfossils of diatoms, microscopic algae that require sunlight to live. Their presence indicates that the lakes were once open to the atmosphere, connected to the ocean during warmer periods millions of years ago. This means that Antarctica has cycled between glaciation and thaw many times, with each phase reshaping its biosphere. The ice may seem permanent, but it is merely one breath in the planet's longer respiration. This cyclical pattern echoes in the rocks beneath. Magnetic readings and isotopic analysis show alternating periods of volcanic activity and dormancy, synchronized with the advance and retreat of ice. When glaciers grow, their weight suppresses magma flow. When they melt, the pressure lifts, triggering eruptions. These eruptions release greenhouse gases, warming the atmosphere and starting the cycle anew. It is an elegant feedback system, self-regulating yet precarious. Human influence now accelerates it beyond natural rhythm, adding heat faster than the Earth can absorb. The result is imbalance, a rhythm broken mid-beat. Still, even imbalance generates adaptation. As the edges of the continent warm, new ecosystems emerge in places once sterile. Mosses and lichens spread along coastal rocks. Krill populations migrate farther south, feeding whales and seals that follow the shifting ice. On the Antarctic Peninsula, penguin colonies once limited to milder islands now nest on newly exposed ground. To ecologists, these are early indicators of change. To the planet, they are simply continuity, life filling every niche as conditions permit. The same principle applies to the microscopic world. Beneath thinning ice shelves, mats of algae flourish in pockets of filtered light. They become the base of an entire food chain, feeding amphipods, fish, and larger predators. Scientists studying these oases describe them as subglacial gardens, vivid and self-contained, pulsing with color beneath layers of translucent blue. They are both beautiful and unsettling, reminders that life does not wait for permission, it simply adjusts. This adaptability forces a shift in perspective. The Antarctic ecosystem, long viewed as fragile, may also be one of the planet's most resilient. Its organisms have survived extremes of temperature, isolation, and radiation for millions of years. The question now is not whether life can endure change, but whether human civilization can adapt as skillfully. For biologists, every extremophile discovered here doubles as a metaphor for resilience. For philosophers, it is evidence of a pattern larger than species, persistence as the fundamental law of existence. Parallel to these biological revelations, geophysicists have been monitoring heat flux rising from the bedrock beneath the West Antarctic ice sheet. Radar instruments detect anomalies consistent with volcanic plumes. These heat sources melt the ice from below, feeding the same lakes that harbor microbial life. They also accelerate glacial flow toward the ocean, influencing global sea levels. The discovery underscores how interconnected the planet's systems remain. Geological fire sustaining biological persistence, both shaping climate. What once seemed a frozen relic turns out to be alive with motion, as if the continent breathes from its depths. That breath manifests even in sound. Seismic sensors record the creaks and groans of moving ice, each vibration an echo of friction miles below. When translated into audible frequencies, these signals resemble the murmur of waves or a slow heartbeat. To some researchers, the sound conveys more than data. It evokes emotion, a sense of listening to the planet in real time. Artists who collaborate with scientists have turned those recordings into music, blending empirical observation with aesthetic reverence. In those compositions, one hears the deep rhythm of geological time translated into human hearing, proof that even science can be a form of listening. Such collaborations hint at a broader transformation in how humanity relates to the Antarctic. Once a target of conquest, it has become a teacher. The treaty system that governs it enforces cooperation, forbidding militarization, and emphasizing shared stewardship. In this sense, the continent is not merely a place of research, but an experiment in coexistence, a test of whether nations can manage a common resource without conflict. So far, it remains one of the rare successes in global governance. Scientists from rival countries share data, equipment, and shelter, bound by necessity and respect for an environment that tolerates no arrogance. Antarctica may be harsh, but it is also egalitarian. Cold does not discriminate. As technology advances, the frontiers of exploration shift downward and inward. Autonomous robots now swim through subglacial tunnels, mapping caverns and measuring chemistry. Drones traverse the surface during months of darkness, guided only by GPS and starlight. Artificial intelligence processes terabytes of radar data, revealing patterns invisible to the human eye. The result is a digital Antarctica, an ever-updating map, where every pixel corresponds to new understanding. Yet, even in this precision, mystery persists. Each solved equation uncovers another layer of complexity. The ice refuses to yield its full story all at once. For those who work there, this perpetual incompleteness becomes its own kind of truth. Antarctica teaches that knowledge is asymptotic. We approach but never arrive. Every answer dissolves into deeper questions: how far the heat reaches, how long the microbes have lived, what happens when the last glacier carves into the sea. The continent's lesson is patience, the same patience that allowed forests to become ice and ice to shelter life again. When viewed from space, Antarctica glows faintly against the black ocean, its ice reflecting sunlight into the void. Astronauts describe it as the most luminous region of the planet, a mirror at the end of the world. From that distance, all distinctions vanish. The lines between mountain and glacier, between human and environment, between past and future. What remains is a single white spiral, rotating slowly with the Earth, holding within it the memory of creation and the promise of renewal. The silence of Antarctica, therefore, is not the silence of emptiness, but of comprehension, an equilibrium achieved through time. It is the pause before revelation, the breath before speech. Each year, as the ice sheet shifts and the wind reshapes its surface, the continent writes another verse in its endless dialogue with the sky. We are only beginning to learn the grammar of that conversation, and every expedition, every sample, every recorded tremor brings us one word closer to understanding the planet's own voice. In that voice we hear a truth both simple and immense, that the Earth has always known how to begin again, and somewhere beneath the ice, in darkness unbroken for eons, it is already preparing to do so once more. The closer the world listens to Antarctica, the more it seems to realize that the continent is not a frozen wilderness at the edge of civilization, but civilization's hidden center of gravity. Every climate model, every global forecast, every attempt to understand the planet's next century revolves around the same white vortex of ice. What happens there will decide the shape of coastlines, the rhythm of seasons, and the memory of species. Yet as its ice melts and its secrets unfold, the story of Antarctica becomes less about what we can extract and more about what we can preserve. The understanding that this place, above all others, teaches endurance through change. The present moment is one of paradox. The same melting that alarms the world is also releasing evidence long sealed away, fossils, sediments, and the faint signatures of vanished climates. Near the Transantarctic Mountains, geologists recently uncovered fossilized leaves of ancient beech and podocarp trees, preserved in permafrost since the Pliocene. Their structure shows that only 3 million years ago, parts of Antarctica were temperate, with rainfall and running rivers. Pollen grains extracted from nearby ice cores confirm it. The continent once supported entire ecosystems where tundra now lies silent. Each fossil functions like a mirror, held up to the present, reminding us that the frozen world is not eternal, but one chapter in a long oscillation between life and sleep. That oscillation defines the rhythm of the planet's deep time. Ice advances, retreats, and returns again. The new question is whether the current retreat belongs to that natural rhythm or to the artificial acceleration of an age defined by human industry. Satellite data makes the distinction visible. The rate of Antarctic ice loss has tripled since the 1990s, and the warming of surrounding waters now reaches depths once immune to change. It is no longer a geological process measured in millennia, but a transformation unfolding within a single human lifetime. Even so, the continent's capacity for feedback remains extraordinary. As the ice melts, fresh water flows into the Southern Ocean, creating a lens that alters global circulation. This in turn affects monsoons in Asia, hurricanes in the Atlantic, and rainfall in the Amazon. The poles are the fulcrum on which weather pivots, disturb one, and the entire system sways. Yet within this intricate web there are still buffers, self-correcting mechanisms that slow collapse. The Southern Ocean's ability to absorb carbon dioxide acts as one such buffer, temporarily offsetting emissions. But that generosity is finite. The ocean's capacity is weakening, its waters acidifying, and with every passing year the margin for equilibrium narrows. Despite these warnings, Antarctica also continues to yield new beginnings. In 2022, researchers drilling into sediments beneath the Amundsen Sea found bacteria metabolizing ancient carbon trapped for millions of years. When exposed to oxygen in the lab, they revived instantly, consuming organic matter that had waited since before the last ice age. These microbes, neither extinct nor truly alive during their dormancy, reveal that the boundary between death and sleep is thinner than assumed. They also demonstrate nature's long patience. Systems paused for epochs can restart when conditions align. To the scientists who revived them, it was like watching the planet take a slow, deliberate breath. This capacity for renewal extends to the continent's atmosphere. While the ozone hole once symbolized human harm, it now serves as evidence of recovery. Following decades of global cooperation and regulation, measurements from the South Pole show a gradual healing of the ozone layer, a small but profound triumph of collective restraint. The same air that once carried chemicals of destruction now carries proof that coordinated action can reverse planetary damage. The lesson is simple yet monumental. The Earth is responsive. It listens to what we do. Such responsiveness is visible even in ice movement. Glaciologists have documented new ice quakes, small tremors triggered by the sudden fracturing of shelves. Each event releases sound waves that travel for hundreds of kilometers through the ice. When sped up and converted to audio, they resemble distant thunder or the cracking of colossal glass. These are not random noises but data, the language of transition, the sound of pressure redistributing itself as glaciers adjust to change. Every fracture carries information about stress, heat, and flow. In these vibrations, scientists read the biography of the ice sheet in real time. Amid all this transformation, human presence remains minuscule yet symbolic. Across the continent's expanse, only a few thousand people live through each season. Scientists, engineers, and caretakers of the global experiment. Their days are measured by wind and silence. Each base is a microcosm of humanity's paradox, a technological bubble sustained by fossil fuels, existing within an environment that records the consequences of those very fuels. The contradiction is not lost on them. Many researchers describe Antarctica as a mirror that reflects humanity's strengths and its fragility at once. To survive there requires cooperation, patience, and humility, qualities the modern world urgently needs beyond the ice. Among the most profound shifts in perception has come from long-term ecological monitoring. Near Palmer Station on the Antarctic Peninsula, decades of data show a steady decline in krill populations, the small crustaceans that form the foundation of the Southern Ocean's food web. Their decrease affects penguins, seals, and whales alike. Yet, in parallel, other species move in, fish and jellyfish more tolerant of warmer waters. It is not extinction but replacement, a biological rearrangement, echoing the patterns of earlier warm periods. Nature does not vanish, it reconfigures. For humanity, however, adaptation on such scales is slower. While biology adjusts, the physical ice remains a chronicle of our impact. Cores drilled from recent snowfall already show traces of industrial pollutants and microplastics, microscopic confetti of civilization drifting from every continent. They land on the white surface, melt slightly in the sun, and refreeze, tiny time capsules of an age defined by consumption. To scientists, these inclusions are both contamination and evidence. They mark the moment when human activity became not just visible but geological, woven into the planet's fabric as indelibly as volcanic ash or meteoric dust. Yet Antarctica does not respond with hostility. It continues to reveal. Deep radar scans beneath the East Antarctic ice sheet have identified an entire buried landscape of valleys, lakes and river channels, untouched for over 30 million years. The contours suggest a world frozen in mid-motion, preserved like a photograph of a vanished epoch. Each new map expands imagination as much as knowledge. What lies beneath may never again see the sun, but through technology it becomes visible, a reminder that discovery is often less about reaching and more about revealing what was always there. These glimpses into the unseen strengthen a growing conviction among scientists that Antarctica is less an archive than an organism. Its cycles of freeze and melt resemble heartbeat and breath. Its subglacial rivers behave like veins. Its magnetic and seismic pulses correspond to nervous systems scaled to planetary dimension. This metaphor is not sentiment. It arises naturally. The continent behaves as though alive, because in a systemic sense it is. Energy circulates, matter regenerates, feedback sustains balance. To study Antarctica is to study Earth's metabolism. Within that realization lies an ethical imperative. If the planet is alive, then stewardship replaces ownership. The Antarctic Treaty already embodies this idea, transforming territory into trust. But as the ice retreats and resources become accessible, minerals, methane, freshwater, the temptation to exploit will return. The question that looms is whether humanity can honor the silence it once promised to preserve. Every decision made now will echo through millennia of ice formation yet to come. At the same time, there are moments of hope that suggest a deeper cultural shift. In 2048, the treaty's environmental protocols will come up for review, and nations are already planning not to loosen but to strengthen them. Some propose expanding the continent's protected status into a permanent World Heritage Zone, ensuring that no extraction ever takes place. If achieved, it would mark the first time humanity collectively decided to leave a resource untapped, not from weakness, but from wisdom. Perhaps this, more than any scientific discovery, is Antarctica's final offering, the possibility of humility. In its vast emptiness, it demonstrates abundance. In its silence, it demonstrates communication. In its hostility, it teaches care. The data speak of melting and imbalance. Yet within that same narrative lies resilience, a continual act of renewal that defines both life and planet. As researchers complete their field seasons and the long winter closes in, they often describe a final ritual, standing outside away from generators and lights, and listening. There is no sound but the whisper of wind, the soft shifting of snow grains across ice. Yet within that quiet, one feels motion everywhere. The slow rearrangement of oceans, the drift of stars above, the steady pulse of the earth itself. It is not the end of the world they hear, but its continuation. For all its warnings, Antarctica remains a promise that renewal is still possible, that the same planet capable of freezing entire continents can also thaw them back to life, and that understanding, if paired with respect, can transform catastrophe into comprehension. The story now turns toward that comprehension's final horizon, a moment when the planet's oldest archive and its youngest civilization converge, forcing humanity to decide whether to read the record or become another layer within it. If the ice could speak, its voice would sound like distance measured in centuries. It would tell of warmth that came before the cold, of forests turned to crystal, of light bending beneath snow and emerging as memory. It would remind us that nothing on earth is still, that even silence moves, and even absence has gravity. Antarctica, the world's oldest mirror, now reflects a new question back at us. What will we leave frozen for those who come after? Across its interior, satellites trace fractures like veins, blue against the white. Some run for hundreds of kilometers, marking where the ice begins to thin, where the continent exhales. These cracks are not random, they follow the buried mountains below. the same ridges that once guided rivers through Gondwana. When the ice groans, it is those ancient contours shifting again, as if the land beneath were remembering how to move. The sounds reach the surface through seismic echoes, pulses that repeat every few hours, regular as heartbeat. Scientists record them but rarely speak of their effect. They describe standing on the plain and feeling the tremor rise through their boots, a vibration without source, vast and slow. It is not a quake, it is a rhythm, a planetary metronome marking the pace of change. The rhythm has quickened. Meltwater flows faster through subglacial channels, and the glaciers feeding the Amundsen and Ross seas accelerate toward the coast. Yet amid this motion, a strange equilibrium persists. As one region loses mass, another thickens through snowfall. As ice slides seaward, it cools the ocean beneath, forming new crystals that grow upward like inverted frost. The planet adjusts itself continuously, improvising stability. But that balance now relies on delicate timing, a synchronization of currents, winds, and temperature gradients. If one falters, the others must overcompensate. That interdependence is both the Earth's strength and its vulnerability. In recent years, airborne radar has revealed yet another secret beneath the ice. An ancient river system, the size of the Rhine, still intact, carved into bedrock, long before glaciation began. Its valleys are filled with sediment, its deltas preserved under kilometers of frozen water. The discovery rewrites the continent's geography, suggesting that Antarctica once drained through a vast network of rivers flowing north into a prehistoric ocean. Each buried channel testifies to a time when the poles were temperate and the world's map unrecognizable. In its pattern, scientists recognize the same fractal geometry that governs rivers everywhere, from Amazon tributaries to Martian gullies, proof that erosion, like life, follows universal laws. The more these patterns emerge, the clearer it becomes that Antarctica is not isolated from the rest of the planet, but central to it. Ice cores taken from Dome C now carry air bubbles over 800,000 years old, capturing every oscillation of carbon dioxide and temperature since early humanity learned to make fire. Those tiny pockets of air show how closely climate and civilization intertwine. When CO2 rises, ice retreats. When it falls, ice advances. The planet breathes through the poles, and our industries have become part of that respiration. Each ton of carbon burned is a syllable added to the record, sealed beneath future snow. In those layers, researchers can even trace volcanic eruptions, pandemics, and wars, each leaving chemical fingerprints invisible to the naked eye. Lead from Roman smelters appears faintly in ice dated 2 millennia ago. Soot from the Industrial Revolution thickens the bands of the 19th century. In more recent strata, traces of plutonium mark the era of nuclear testing. The ice, indifferent, records it all. It becomes the most honest historian on Earth, unbiased, incorruptible, fluent only in evidence. From this perspective, human history compresses into a thin line, a brief fluctuation in an otherwise steady rhythm. Yet it is within our power to widen or narrow that line. The decisions made in this century will determine whether Antarctica's record continues as climate memory or becomes obituary. Still, even in the face of accelerating change, the continent resists despair. For every sign of loss, there is a gesture of persistence. New microbial colonies colonizing melt zones, whales returning to ice-free waters, auroras flaring brighter in magnetically active skies. Creation persists alongside collapse, as it always has. This coexistence defines the paradox of the present. The data show crisis, but the phenomena themselves reveal adaptation. When satellites measure thinning ice shelves, they also detect new plankton blooms beneath, feeding fish and seals. When glaciers retreat, they expose rock that seeds the growth of moss and lichen. Nature does not mourn the past, it reorganizes it. Even extinction feeds continuity, turning carbon into soil, heat into motion. What humans perceive as decline is often transition viewed too closely. That perspective shift extends beyond biology into consciousness. For many who have lived on the continent, The transformation is internal. Months of darkness recalibrate perception. The horizon expands beyond measure, and time loses its usual texture. Scientists describe how, after weeks without night or day, their thoughts begin to mirror the endlessness around them. The separation between self and environment dissolves. They start to understand the planet not as backdrop, but as organism, and themselves as one of its functions. The longer they stay, the more the boundary blurs. When they return to the world of sound and light, they carry with them a subtle alteration. Some report heightened attention to small things, the color of air before rain, the resonance of footsteps on stone, the faint rhythm of their own pulse. Antarctica trains perception to notice scale, to hold both immensity and detail in a single frame. That awareness may be its quietest gift to civilization, teaching us to think in centuries rather than days, to measure success not in growth but in balance. As the 21st century enters its midpoint, technology finally allows us to see Antarctica almost in real time. Satellites orbit hourly. Sensors transmit data through polar night. The continent is more visible now than ever, and yet it remains profoundly mysterious. Beneath its precision maps lies an element science cannot quantify: awe. The same feeling that guided explorers through storms still moves researchers who spend their lives decoding the ice. They know that no equation can replace the moment of standing alone on a plain that stretches beyond imagination, where the air rings with silence so complete it feels like music. In that silence, one truth becomes impossible to ignore. The future of Antarctica is inseparable from the future of everything else. If the ice continues to melt, oceans rise. If oceans rise, cities flood. If cities flood, civilization shifts. The chain is unbroken. But if restraint holds, if emissions fall, if treaties endure, then equilibrium remains possible. The planet will adapt either way. The question is whether we will adapt with it or against it. Among the proposals shaping that future is a radical one: to designate Antarctica as a permanent sanctuary for planetary research and renewal, a site where human impact is minimized and restoration prioritized. It would mean using the continent not as frontier, but as refuge, a living archive for species and ecosystems threatened elsewhere. Seed banks already exist in Svalbard. Antarctic equivalents could one day preserve genetic diversity for the entire biosphere. In this vision, the frozen South becomes not the end of the world, but its safeguard. Such ideas once sounded utopian, yet history shows that every major shift, abolition, suffrage, environmental protection, began as utopia before becoming necessity. Perhaps the same will be true here. Already young scientists speak of planetary citizenship, of viewing the Earth as a single shared experiment. Their mentors, hardened by decades of fieldwork, now echo the sentiment. The cold seems to breed consensus. Survival requires humility. And so the story closes where it began, not with conquest or fear, but with wonder. The ice that once concealed forests now preserves evidence of their rebirth. The winds that erase footprints also sculpt new landscapes. The darkness that isolates explorers reveals galaxies overhead. Antarctica's contradictions have always been its truth: warmth within cold, life within silence, motion within stillness. When the final light fades from the austral summer and the continent returns to night, its surface gleams faintly under the southern aurora. The green arcs ripple across the sky like veins of light, connecting horizon to horizon. For a moment, it seems as if the earth itself is exhaling, relieved to know it still remembers how to breathe. That breath, invisible but real, joins everything: air, ocean, life, thought, into one unbroken cycle. And beneath it all, the ice waits, not as grave but as archive, not as relic but as seed. Its silence is not an ending. It is a promise that the world, in all its fragile brilliance, will continue to write its story long after we have learned to listen.